Good morning, sir.
Morning.
Good morning, sir. Good morning. Sir, I'll make you the presenter. Sir, may I start?
Yes, I can start.
Okay, okay. Thank you, sir, for coming. So it is a welcome to all for a day two of Serve sponsored workshop on AI and ML application in a healthcare. It's my privilege to introduce our keynote speaker, Professor Samerandra Dandapat. He is a member of IEEE. He received the BTech degree in the Electronics and Communication Engineering from Motilal Nehru National Institute of Technology, Allahabad in 1986. The MTech degree in Electronics and Communication Engineering from the Indian Institute of Technology, BHU, Banaras in 1991. The PhD degree from the Department of Electronics and Electrical Engineering, Indian Institute of Technology, Kanpur in 1997. He has been a faculty member with the Department of EEE IIT Guwahati since 1997. He has been a faculty member with the Department of EEE, where he was the head of Department of EEE from 2005 to 2006, the Dean of Student Affairs from 2006 to 2008, the Dean of Administration from 2009 to 2012, and is also associated with the Sports and Healthcare Engineering Research Center. He was also the founder dean with the IIT Patna from 2008 to 2009. He was a visiting research fellow with the Nanyang Technical University, Singapore from 2003 to 2004. His current research interests include the cardiovascular signal processing, stressed speech processing, and fundus image processing. So this was just a brief bio for his tremendous work. So now I request Dr. Anurag sir to felicitate Professor Samerandra Dandapat sir with the token of appreciation. Then we will start, and I would like to invite then after that Professor Samerandra Dandapat sir to start the lecture. Sir, please, we'll start with the felicitation, sir. Sir, it's a virtual one. So,
How to felicitate? Let us start.
Very good morning, sir. Thank you very much.
Yes, Anurag, anything you want to say?
Yes, sir. Sir, it was just customary though, but it's a tradition to give a small token of appreciation for every speaker. So we are giving it for you also. We are expecting you physically here, but somehow it could not happen. But still, please accept our Momento virtual mode. We will send it through post. Okay, sir. Thank you very much for joining
Thank
us.
you,
We will start. Thank you, sir. Thank you very much.
Acha, is my audio clear? And
yes, yes, sir. Sir, audio is clear. Yes,
are you
yes,
able
sir.
to see my PPT now?
Yes, sir. Yes, sir. PPT is the I will do the full screen. Yes, sir. Sir, I am moving the camera in front of the audience up now.
Okay.
Okay, sir. So now it's visible. I think the PPT is also visible, sir. You may start, sir. Thank you.
Very good morning to all of you. I would like to thank IIIT Raipur for giving me this opportunity to give you a presentation and share my ideas on this topic, AI for cardiovascular signals. What I have thought, I was discussed with Dr. Anurag, that it will be nice if we make it an interactive session instead of, because as I know the audience background, some of you are actually new researchers, I can say you are starting your research career. So whatever your interest or the questions in your mind about artificial intelligence related to healthcare or specific to cardiovascular signals, we can discuss. That will be, I think, more interesting than completely giving a talk from my side. Right. So I'll just introduce you a few topics, then and you can stop me at any point time and you can ask. So it will not be a very boring session if you go like that. And whatever your interest, and whatever I have experience, I can share with you. Right? This is all right? Yes, I would like to have some response from the audience.
Yes, sir. Yes, sir.
Okay, okay. Then to start with, I'll show you, this is a photograph of our campus, IIT Guwahati. We have a lake, and behind it there is a hill. I call it typical Kailash Manasarovar combination. Our version is here in IIT Guwahati. You can feel it, beautiful campus. And this is our academic complex. Behind it is the mighty Brahmaputra river is there. The hill that you can see here, that is the Kamakhya hill. These are the various areas that we work at IIT Guwahati in our lab. We work on cardiovascular signals like ECG signal, phonocardiogram signal, seismocardiogram signal. We also work in speech signal processing, specifically pathological speech in general, I can say, stress speech analysis, out of breath speech analysis, like that. Also, you work on retinal images like fundus image, OCT image, optical computed tomography image, like that. These are some laboratory facilities where the research scholars, PhD students recording. These are the left side is the fundus camera, right side is a OCT camera, optical computed tomography, where they are recording the retinal images. And here we have a wirelessly, we can record the physiological signal like ECG. They are recording wirelessly. This is again, and wirelessly they are recording, though the wires you can see that is for other signals simultaneously is they are recording phonocardiogram and PPG signal. That's why some wires you can see. Otherwise, this black electrodes, they are actually wireless electrodes. And this is that they're recording it, a small video how they are doing it. We'll skip it. And this is just to give you an overview of how healthcare has evolved over time. So to see that, we can see our body as a gross body, whatever our physical body, that you can say gross body. Also, scriptural term, this is called the food seed. Whatever the food we take, the type of food we take, that's how the body is there. Inside that, we have all types of biochemical processes in the body. The biochemical processes are controlled by an electrical body. All of you know that we have nervous system, electrical signals are being transferred from or transmitted from central nervous system to peripheral organs like motor organs and to different types of other organs for various functioning, for controlling this biochemical body. Then we say there is a cognitive body on which actually research is going on. Not much is known about it, and this just I have put it inside from our scripture I have taken. There's a bliss body is there inside that. Okay, so we can see it how healthcare has evolved over time. So this is a food sheath or the gross body, and typical diagnosis when you visit a doctor ask you whether you're a chain smoker, you consume alcohol, if there is food poisoning. These are all diagnostics targeted to the physical body or the gross body. And the therapies, as you know, therapies, then the doctor advise you for a balanced diet, healthy diet, like that. Doctor advise you. So this is about the gross body. And various medicinal systems, they follow it. It is still going on. Now also, the diagnostics and therapy most of the time are targeted at the gross body level. The suggestive, the food habits, there's a therapy part that inquire about your food habits, that is the diagnostics part. Then before almost I can say 200, 250 years, what we say the modern medical science, that was basically targeting the biochemical body inside the physical body. And the typical diagnostics, that is being followed are like your blood test, urine test, stool test, biopsy, these are actually biochemical tests, which are targeted to diagnose if there is any problem in the biochemical body. And the therapies, obviously, like we take medicines, which are nothing but chemicals we take. That is to um, change any abnormality in the biochemical process. So this is going on for last 200 250 years as the modern medical science, or other medicinal practices like Ayurveda and all. They also target this body, which is being claimed is like a much more old system. But anyhow, the system is basically targeting the biochemical body, which is inside the gross body or the food sheath, the diagnostics as well as the therapy. Now, this biochemical processor, all processes are controlled by an electrical body, which is there in us. Like some of the organs, like heart and all, are autonomous organs. They have their own electrical generators called natural pacemaker. And otherwise, most of the electrical system, the generation starts at the central nervous system, where electrical signals are being generated and transmitted to the various organs, and the organs functioning and all are controlled by that electrical body. So you can see the electrical body is something like this. So all over the inside the biochemical process, you can see the subtle body that I am modeling as an electrical body. And this is actually almost 100-year-old. People know, and various diagnostics that has come up looking at the electrical body are like analyzing any disease or diagnosing any disease from this electrical signals recorded body, like electroencephalogram signal, that is the brain signal, we say electrocardiogram signal, that is the signal recorded from the heart. There are hybrid systems like this. I'll say that these imaging systems are actually not targeting the electrical body. We convert something like anatomical picture or a physiological picture to an image. So this, I can say, diagnostics based on the electrical body. The therapies is coming up like anything. Already you know about the pacemaker. Pacemaker is an electrical device that is put inside the heart. If our natural pacemaker has any problem, then this electrical device is put inside, and it's already in practice for more than 50 years, very effective. And recently, things which are in practice are like deep brain stimulator, like Parkinson disease. This is a neuromotor disease. So people put a device in the motor cortex in the brain that can control the Parkinson. And we have seen that now you can guess that any diagnostics or therapy, if it is targeted at the electrical body, then it will have a better effect or more permanent effect compared to what has been targeted to the biochemical body or what has been targeted at the gross body. So this is how the science is advancing. Slowly and slowly, you can see in hospitals, instead of biochemical diagnostics are replaced by electromedical diagnostics and electrical related therapy. So the hospitals also are looking nowadays more and more clean, because the biochemical processes have their own disadvantage. And that's how the therapy and diagnostics are also becoming more and more effective. And the next is the cognitive body. Now, research on this cognitive body means it is, people are assuming but how the electrical signals are starting and all, that is a part of cognition. A lot of research all over the world are going on to know about this cognitive system in our body. Though it's a very initial stage, there is no breakthrough till now. We are expecting another 20-30 years time, breakthrough may come. Now you can imagine, if you can understand this cognitive system, then our diagnostics and therapy will be more effective. So that is how the science or technology is progressing. And then the bliss body, just I have copied it from Indian scriptures, the way we say different chakras and all. People claim these things are there. Also, we feel some truth is behind there, but not very scientifically established now. But still, a lot of work people are various other areas people are trying to do to prove these things. Okay, now coming to how AI system has evolved. Now, AI system, of course, if you look at the history, this has started in 1950s. That time people thought that how you can make the machine think like a human brain or a human being and work with that input, how machines can be designed. The effective system started appearing late 60s or early 70s, and especially they appear as expert system or expert system based artificial intelligence systems, where actually this is where actually some, you can say this is the time when actually people started seeing an application of AI, whatever being thought at 1950s, the results have started coming in late 60s and early 70s. So the first thing that is came up is expert systems. So expert system, what is there? Like, okay, for there are rule engines, like, if I am going for a diagnosis, how the doctors diagnose, they look at various parameters. It is sort of, I can think of various rules are there. Based on those parameters, doctors diagnose. So those are like rule engines. So various things, not only in healthcare systems, but also other systems, you can think of designing expert systems where we can the rules or how the decisions are being made, and the rules are formed from a knowledge base. Knowledge base, that whatever we have learned over the years, that how a system works, that we put as the rule engine. And then when we give some set of parameters as input, then the expert system can predict whether it's a diagnostics or any other application. Accordingly, the system can predict. So this is how expert system started in 70s, I can say, and 80s they become very popular, and this is how the system evolved. So as the knowledge base becomes stronger and stronger, so the systems came up with a lot of promises. So the knowledge base is created by the human experts, like the doctors, they can create the knowledge base. Then the engineers can put it or design, we can say, from the point of view of modern day perspective, I can say, softwares, where actually expert system they can design, taking the knowledge from the experts, and which can be used by the user by giving input to the system. And so to start with, initially deterministic inference engines were created. Deterministic means, okay, the rules are straightforward. If you have fever, if your blood pressure is this much, then this is the disease. These are all, you can say, deterministic inference engines. Then slowly people understood that these are of not much use, because instead of deterministic, how the doctors decide, it's not purely that if the fever is 100, there is this disease. If fever is 102 Fahrenheit, this disease. It doesn't go like that. The way the doctors decide, or any diagnostic system, even if in other applications, it's not purely, unless it is a purely engineering system, most of the time diagnostics are probabilistic based. So that's why people advance towards probabilistic inference engines, where actually probabilistic models people try to use. So that's how the expert systems advance from deterministic inference engines to probabilistic inference engines. And there are various softwares that time came up in 80s, Dendral, Machine. These are all in the healthcare area and other areas people use, fixed dates, like that. There are limitation of this expert system. So there is a boom in designing the expert, lot of money all over the world, industries put into designing expert systems. A lot of promises were there, but there are limitations. And because of these limitations, suddenly after 80s, at the beginning of 90s, everything stopped. The limitations basically come because the response of an expert system may get wrong if the knowledge base contains wrong information. That is obvious. Like a human being, it cannot produce a creative output for different scenarios that you can expect. So expert systems are like, still, even if we make it probabilistic, but still it cannot work for all type of situations. Like its maintenance and development costs are very high. You can think of expert systems when you design, it will be always problem specific. So if I am handling a different type of disease or a different type of problem, I should have a new expert system. That is where the cost increases. And that is where slowly these things become more and more unpopular, you can say, or the knowledge acquisition for designing is much difficult. So for every fine change, we require a different set of knowledge. And that is where the cost increases. And because of this knowledge acquisition itself was very costly affair and difficult actually in situations. That's why. And we need to have dedicated expert systems for various problems. And slowly people lose interest. They did not find the promises which were there at the beginning, did not work out. That's why almost in 90s, this actually stopped. Suddenly it went away from the market. So like another limitation was that it cannot learn from itself and hence requires manual updates. That was another very big limitation was there. Then slowly, simultaneously, developments were going on in other areas like speech signal, which normally we say is the father of all these developments. The speech signal analysis, synthesis, recognition, this was actually going on for a long time, and a lot of developments were coming up. Like the speech paradigm, like automatic speech recognition, shifted from, I can say, from the general rule of speech recognition system to statistical speech recognition systems. So where actually people use statistics or exploited the statistics present in the signal for recognition purposes. Similarly, ECG signal has contributed completely a field that is called adaptive signal processing. Like especially Woodrow in early 70s designed this to separate fetal ECG from the maternal ECG. When the baby is in the womb, then if you record ECG signal, then the maternal ECG will be superimposed on the fetal ECG. There are two hearts. One is the baby's heart and the mother's heart. And to separate them out was a big challenge because both are heart signals. Their characteristics were same. So it was a challenge. So there Woodrow actually came up with the idea of this adaptive signal processing, which later on has applications in many areas. So which is sort of like a learning process type of things came up there. Then statistical signal processing, where actually people started taking decision not purely based on some models, fixed deterministic models, but based on the statistical information present in the signal. So that was coming up. Then the natural language processing was coming up. You know, natural language processing nowadays is at the front end of all AI systems. Like why it is required, we need to communicate with the machine in a natural way. So for that, actually, the front end requires a speech recognition system. When I'm talking to the machine should recognize what I am speaking. But the context in which I am speaking, that can be decided by a language model. Like the same thing, we know that we can express in different phrases. So that is why natural language processing is very important. Then, of course, slowly machine learning, all the decision making started becoming statistical based models people started using. Now, this has happened because many things scientifically, though we know there is causal effect always is there. Whatever is happening, any weather change is happening, there are precise reasons behind it. But in many such natural phenomena, we do not know the exact scientific reasons behind it. As the science has progressed, still we are unknown, or we do not know about like a lot of things about our health. You know that very good example is the cancer. So there is no precise reason that people know the causes of cancer. Similarly, almost all physical situation or the natural situation, we have not completely explored the reasons behind them. So then people started using the statistics is about some characterizations we try to find out from the signals or from the data. And then we try to predict. And then people saw that in a lot of applications, this is successful. People found very successful, like speech recognition. all areas of speech and various multimedia image segmentation, recognition, people got success. That is why instead of knowing the exact reason, we can find out the statistical parameters and can, though it is not, I say that statistics actually is to cover up our ignorance in science. But still it works in a lot of applications. That's why it became popular. Suddenly it became popular for last 20 years, I can say. And it has taken up as a field. Then so recently this deep learning technique, I'll talk about it, why it has become popular and what are the limitations. So all these contributions from different fields, now people suddenly, before 10 years, people awake to, and also there is another thing for processing these statistical things like typical machine learning things we require, because for evaluation of statistics, we require huge data. Now that huge data processing, which was a limitation because of the computational limitations earlier till 90s. Till 90s, machines were not that fast. So that is what the limitation was there. So that limitation we overcame recently, I can say last 10 years. Now our machines are very fast. We have computational units like GPUs and other things available. We can handle huge data. That is why the statistics become popular. That's how machine learning became popular. So mostly the credit goes to the computational efficiency that is available to us in present day. Then the real science that we know behind these processes. Okay, so that is where the machine learning has become popular, and because of this, the AI has again, which has gone into a deep sleep in 90s, again it has woken up recently, and now all types of AI applications people see. Industry, of course, is very enthusiastic, and various applications they have started showing, and that's how it is becoming popular nowadays. Anyway, I'll just keep these slides. So data is critical. So then coming to a AI system, I can say, or an automated diagnostic system from the healthcare point of view. What are the different blocks are there? They are, so like suppose we have a pre-processing block, and where the pre-processing means any signal or image I'm assuming from which signal data or image data we are going to predict something. So pre-processing requires, if there is any noise there, we have to clean it. There may be some normalization processes. There's a pre-processing. The feature extraction is important because in any data, there are various information are there. Like the speech that I am talking now, you know that it has intelligence. You are able to understand. You know the language I am talking, so you are able to understand. That is called intelligence. Those who know me, like they can listening to my speech, same speech, they know that who is speaking, right? So there is a speaker information. Like whether I am really speaking in an angry voice or in a request voice, that also can be decoded. That is called the emotion information. Whether I have any health related problem or not, that also can be decoded. That is a health related. You know that what I want to say that even if this single signal called speech signal, there are many types of information are there. And you may be interested in particular information like the intelligence. Like from the machine point of view, you may be trying to recognize what is being spoken or who is the speaker. That is a different type of information. What's the emotion? That's a different type of information. Now, it will be better for after whatever we are going to give input to the machine learning, if I can extract the specific information, then the machine learning tools will work better. Like if I am interested in the intelligence information, I should extract the intelligence related information from the speech. Though it's the same data, same signal, if I am interested in the speaker, I should extract a different type of information, which we call it as speaker specific information from the speech. If I'm interested in emotion, decoding the emotion in the speech, then I should extract a different type of information. That is where this feature extraction block is important. So, though whatever data that we are going to process or whatever signal image that we are going to process, all these things contain many different types of information. And our interest lies in a specific information in the image or in the signal. So we should know how to extract that. That's why the feature extraction block. Then whatever the features we extract, that we give input to a machine learning tool. And then we train the tool, then we use it. That is how we can implement it as a diagnostic decision or an AI system. This is how I can say a brief view of a present day AI system. Now coming to cardiac signals. So anything you ask me here? Anything you'd like to ask me? Yes?
Hello, sir.
Yes.
Sir, I would like to know that things or happenings which don't come in the framework of cause and effect, are we trying to solve them using machine learning?
Yes, yes. I could not get your question properly. Can you repeat it?
Like you said in the. Hello, sir.
Yes.
Yes. I would like to know that things or happenings which are not coming in the cause and effect framework, are we trying to solve them using machine learning?
Yes, that is the precise thing. The cause and effect is always there. Like for every phenomena, there is cause and effect is there. Nothing is happening accidentally. Like weather, any change in the weather, like today's weather in Raipur, like it has its causes, right? But we are actually based on the progress of science, we know few things, but we don't know the complete picture, right? That is where we take advantage of this statistical characteristics, or we have 100 years data about Raipur weather, and from that we try to predict. That is how the things go. Like whatever if you any signal, any data you take, if you are looking at a phenomena, there is precise cause and effect relationship is there. But based on the progress of science, we are not aware or we do not know all the things. Like I was giving an example of cancer diagnostics. Like we don't know anything about how cancer happens, but we know that if somebody smokes, the probability of getting cancer is higher. Like that, few things we know. Completely we don't know is not correct. Few things we know, but we don't know the complete picture. That's why we are not able to predict it in a cause and effect model. If I have, that is where we take help of statistics or probabilistic models. That is how, and this taking help of statistics and probabilistic model, which was earlier has a limitation because we had limitation in terms of the computational power earlier till 90s. Slowly, as with the advancement of VLSI, VLSI technologies and also computer hardware is improving. So the machines becoming faster, we are able to handle large data sets, because statistics means if you want to find out the statistical characteristics, we require huge data. And because of this advancement in, you can say, VLSI and other advancements, we are now able to acquire huge data. And also because the efficiency of the computational machines, present day machines, we are able to process them also. That is how all the things means together acting towards one thing is that to our ignorance. Second thing, now the computational efficiency is there. Now data is available with us. So that is where these things are becoming popular. Did I answer your question to some extent?
Yes, sir. So, sir, can we say that the machine learning and deep learning helps us to put them into the cause and effect framework? We would like to put them in the cause and effect framework, right?
At present, whatever I told, that is how it is going on. Like you imagine, suppose I can answer it like this. Weather prediction in 70s. How it used to happen? In 70s, only people used to use like whatever 100 years weather in Raipur. And from that, people try to find out the mean value. And okay, 9th September, this was the weather. So in an average sense, that is how people used to predict. Only the first order statistics, I can say, people used to use. But slowly, as you know, nowadays satellite imagery are there with us. We have sensors to measure the pressure condition, pressure, humidity condition at a place. So those parameters are incorporated into the statistic probabilistic models. So the prediction has improved. So that way, the more and more we are actually knowing about the systems through various things like weather case, as I told you, like nowadays satellite images are there. Through various sensors, we know the parameters. So our models, this still we are using statistical models. But then the statistical models are becoming more and more perfect, I can say, are improving. That's why weather prediction has improved over time. And this is what is happening in all fields. Simultaneously, people or scientists or engineers are trying to find out the reasons behind the things. A lot of research all over the world are going on in various fields. So we are getting more and more inputs. Now those inputs are given to the statistical models. So the models themselves are improving. So that's how the things are going on over time. Right? Could I answer something?
Yes, sir. Yes.
So the things are improving. So I can say one way is that statistical models or present machine learning tools are there to cover up our ignorance. That is correct. Also, the models are improving because slowly we are actually finding out the cause and effect, the various parameters. Slowly people are coming to know about those things. So that is why the models are improving. But sometimes what happens, people start using the statistical models blindly. That is a very pathetic thing that is happening in research world. Because unless we should always try, as a researcher, we should try to improve them. And for improving them, we have to do research. We have to find out what is happening. Otherwise, there are a lot of cancer institutes in all capital cities. As I go in India, number of cancer, they will write it Cancer Research Institute. There is no research. As this is negatively, I am saying in a negative way, they are just corporate hospital. Their main goal is to earn money and then really doing research. Nothing negative actually. This is what wherever we stand, only we will have to tolerate that thing because we don't know much. But imagine if that much of effort would have gone into really trying to find out what is the cancer, why this is happening, perhaps we could have been much more in an advanced stage. That is what is not happening in science and engineering. Most of the time, we have to go for earning money, and that is how the models are not improving the way we are thinking that it should improve. That is what is happening, because when these models start giving some results, people want to immediately market in the research world in terms of publications, market in the industry in terms of earning money. That is what is happening. Now that has to happen because ultimately we require money, but only that thing happening is something actually impeding our progress. That is what I can say. Comment at this level. Other things are all right. Okay. Any other query? Yes.
Sir, no, sir, not no any further questions, sir, as of now.
It will be nice actually when you have your questions and I respond. That is will be better thing. Right. Okay. Then we'll start with this cardiac signals. So basically, two types of signals are used for diagnosis. There is a third signal I was telling you, seismocardiogram. That is, you can say, though it is also not a very new signal, but diagnostics have not come out.
This question also we have to take note of it. And check and ask. Because I have kept it that way, make it interactive. Because if you deliver lecture like that,
Good morning, sir.
Yes.
Yes, sir. My question is related to liver cancer, sir. Actually, my father passed 1.5 years because of we are lack of knowledge, early diagnosis, and we just know about this last third stage of cancer, liver cancer. The reason behind of this is gallbladder stone is stuck with liver. And my question is, sir, that in advanced technology, we have any technique for early diagnosis, sir? First stage or second stage, that we can save life.
No, actually, I'm an engineer, I don't know completely. I know how the things are going on, But exactly like the question that you are asking me.
Sorry, sir, just queries in my mind and I'm asking about that.
No, it's all right as a question. This fine actually. How the things are developing that I know, but exactly like suppose gallstone that cancer is there. I am not sure
Yes.
exactly. I can't answer pinpointly at what level of. But you know that the development is not complete actually. We have some developments.
Yes.
Whatever the limitations that we
There are no
always
any symptoms in early diagnosis. There are no any symptom or any problem. Just daily routine life, and then I diagnosed that my father have third stage of liver cancer. It becomes
yes.
a big
I'm
issue
sorry.
for us.
No, yes,
I couldn't.
just as a technical topic, I will address your question. You see, when
Yes,
we
sir.
say that there is no symptom, I'll say that
Yes,
it's
sir.
not correct. It's not correct. Symptom may not be at the physical level, but we don't know
Yes.
how to measure it. We don't know how
Yes,
to
sir.
measure it. Like one area is ECG I'm going to discuss. Before few years, your Dr. Anurag also was working at IIT Guwahati. You know, before few 7 8 years, we don't know how actually this person related information is there in an ECG signal. This is just another example through which I am addressing your question. Like when
Yes,
I
sir.
used to do seminars before 7 8 years, uh,
Yes.
some people used to ask me, sir, can we do biometric application like person identification from ECG signal?
Yes.
If this is the question, then normally I used to answer person related information is there in the ECG signal, definitely, because I have a heart, physically it is a different system. You have a heart, that is physically is a different system. Though as a heart, it's the same organ, similar organ, I can say. But because it is my heart, there must be signature in all its signals or representations, right? But
Yes, sir.
at that point in time, I used to say that we don't know how that information is there. So intuitively or scientifically, if you are questioning me, yes, we have all the information, but we don't know how to get that information. That is where the research has not gone up to that level. That's what I'm saying. Otherwise, as you are saying, the early diagnosis, like symptoms are not there, I'll say that yes, it must be there, but we don't know actually how to know about those symptoms. We don't know how to measure, how to quantify, how to know about those information. That is where actually, that's up to that only we have advanced. So similarly, in this ECG case, we are not knowing, but then suddenly we came across something that we understood how the personal information is there. Now, recently, one of my PhD student, he has completed his work on person identification from ECG signal. So it is now a established field. Now, how the person related information is there in the ECG signal. Sorry, in the ECG signal. Like the speech signal, as I was giving an example, as I am talking, you all agree that various information are there in the same signal. It's just one signal. If you record it,
Yes.
it's just one type of data, right? But you can see
Yes.
the number of information there in this signal. It has intelligence, it has speaker, it has gender, it has age, it has linguistic information, like I am from what type of language background represent, like what is my mother tongue also you can find out, even if I am speaking English. You health information is there. You see so much of different information are there. So as the science progresses, we slowly come to know what is the difference between these information in this, even if it's a one signal. And then as we know more and more, we are able to efficiently process those information. So same thing in other areas of science and technology. So slowly people are trying to find out. Only thing I say that people, they're not much effort. This is what is throughout my life for whole career I have seen the amount of effort that could have gone, because really to know, like suppose about cancer, really a lot of effort is required. It cannot be done by one person. Like whole country, everybody invests into it. Yes, then we can find out. It's not a great thing, and then the progress can. But from that perspective, there is not much. But only that is what is sometimes I comment. Still, some dedicated people are there. They're trying, but that is I don't say it's a very big effort. Otherwise, if you say that early diagnostic symptoms are there or not, scientifically, I can say that it must be there. Only thing we don't know how to actually capture it or how to process it. That is how actually we fail. Only we come to know at an advanced stage in such cases. Right.
Thank you so much, sir, for your response.
Okay. These are very nice discussions, and when you ask your queries and I respond, that is things are more interesting. Otherwise, I can present a topic where actually many things may not be of interest to you. So broadly, as we discuss, this can be more interesting. That's why actually to Dr. Anurag I proposed in the morning that participants to ask me so that I can, whatever little I know from my experience, I can share. Okay, if there is no other query, I will continue with introducing you to this cardiac signals, ECG signal and phonocardiogram signal or heart sound signal. Now,
sorry to disturb you, sir.
Yes, Samrat.
Hello.
Sir, one more query is there from.
Yes, please ask.
Sorry to interrupt you, sir. Actually,
Yes.
my question is going to model overfitting error. If I have construct a deep learning architecture and I have less data set, so how I can predict our model is going underfitted or overfitted?
Say, if I will ask you why deep learning you are using?
Basically, sir, I was trying to build a model by using the CNN, convolutional neural network.
Why you are using convolutional neural network? Ask you
For speech identification, sir.
speech identification.
Yes, sir.
No, I could not get the problem.
Actually, sir, I was trying to build a model by using a speech data set, and I was taking features as a spectrogram in image format.
Okay.
And then I was trying to build a CNN model. But unfortunately, our data set is too less. So I was trying to get augmentation technique, and my output result is not pretty much good over there.
It will not work for less data set. The model itself, that's why from the beginning, this is not a statistical model, but this is also not a deterministic model. So it's a completely nonlinear model. The deep learning models are nonlinear models, you can say. And it's a huge network. Normally you are going to train. The assumption is that you require large data set because it's sort of like I can see it as a blind system I'm trying to train. When we go for cause and effect type of models, there it's not a blind system. And this system is a nonlinear system that you are trying to train. And the underlying assumption is that you require huge data set. Now, of course, people are going for data augmentation for increasing because they have limited data and they try to augment the limited data. From the limited data, they generate more data and that data they use to train deep learning models. Right. So that is the limitation. And so speech, yes, there is a limitation because speech, unless you do a feature extraction, that's what my experience is. Normally, directly, if you are using speech, okay, from spectrogram, it is basically you are converting to a image format and then giving them as input to your CNN model. Still, you require huge data. Or data augmentation, at least you can use for better training of your model.
But sir, in augmentation technique, I have generated some noises over there. So is it affected for our accuracy in particular model?
It depends. It depends actually. There are various data augmentation methods are there. We are not working on that. I cannot precisely comment on that. Data augmentation means you are generating more data from a limited data set, right? So
Yes,
data augmentation, this is basically as data augmentation you are doing it, that is basically the whole idea to train your model. So based on the what type of data augmentation you are using, these models as it started, like this machine learning and now deep learning, the explainability, or I can say really to explain the models, there is no way out. That is where the logical interpretation is a problem with the statistical models and this deep learning models. These are one way of saying that still these are being used as black boxes. Like inside this, we don't know what is there. We are the nonlinear models. We just go on fitting data and train our model. And unlike signal processing models, which are actually science has gone into it, these models still are not, cannot be completely explained that way. So that is why there is a lot of work is going on. People are trying to actually explain various models. Still, people are not successful, but people are trying all over the world. So unless there is a explainability comes, then the answer to your question, you won't get it. Only people try to use, as I told you, people try to use them as data. If you have a limited data, what people try to do? People do data augmentation and then show an improved result. That much people have achieved. Otherwise, you'll have to use, you'll have to record more data or try to get more data and train your model. That is where the research has gone up till now. Explainability almost is missing in these models. That is where is the problem. Actually, there is no logically we cannot explain that if you use it in this way, this will work better. So that is one area, hot area of research in deep learning. How to bring in the explainability, how to explain the model or the different stages of the model, like how many nodes should be there, how many hidden layers should be there, what type of activation function should be there for a particular thing to work better, like that. Some broad things people know for CNN model or nowadays LSTM models, attention-based modules that people try to use for specific applications and show improved results.
And
Yes.
one another
Yes.
question is,
So you'll have to experiment actually with different type of data augmentation, or you're able to hear me.
yes, sir.
Okay. Could I answer to some extent? So this is the limitations because this itself, as I was telling you, to cover up our ignorance. So unless these models are completely explainable level it has reached, that is why I was telling people start using them blindly. That is correct, because some results, some promise, these models show some promises, initial promises, but they cannot replace the cause and effect type of things, which has not happened. And maybe people may be successful in the future. If this explainability doesn't come, or if it will not come into these models, the models itself will go away. This is what in our lifetime we have seen. Many things come and many things after some time this goes away from market. So unless explainability completely comes in deep learning models, automatically my guess is that it's after some time this will be dropped. Now hype is there, but it will continue. There is no guarantee. This happens in science and technology. This happens. Maybe a new thing will come where people may find it more interesting. Like this in science and technology, these things continue. Like today, it is deep learning. We don't know. Maybe after 2 years, 3 years, 5 years down the line, it may not be there in the market completely. Like we used to read about these neural networks in 80s when I was a student. After that, it completely went out of market. 90s. Completely your course ही drop हो गया. All IITs used to offer courses, whatever you are using as deep learning, our courses are being offered. You know that the Hacking book on neural network that was that he has written in 80s, early 80s, not now. And now is the application, as you can see, because that time itself hype was there, but because people could not execute because of the limitation of computational, you can say limitations, so completely things were dropped. Even if people dropped the courses in IITs, I know the courses were being offered in 80s, neural network courses. Hacking's book we have read that time, but then 90s may completely it got stopped. Then again now it has woken up because of the computational efficiency. And we don't know if the explainability and these things could come into these models. Definitely these will continue. This will have their market. Otherwise, automatically they will. This is how the research world goes on. Time to time for 5 years, some height will be there around some, you can say technologies about some ideas. Then after 5 years, they're dead. If it is not taking science or technology to maybe a new model will come. So that is how the things go.
Can I read the question?
Okay. Any other query?
Yes, sir. Hello, sir.
Yes.
Good morning, sir. Sir, my name is Ramchandra. Here,
Yes.
I have been working on cardiovascular diseases by using ECG signals. My question is about PCONet dataset model, sir. The dataset naturally framed with 11-bit architecture and 360 sampling rate. Here, my question is, if I am training my model for 11-bit architecture data with 360 sampling rate, will that model will work for the another database which is not matching with the same thing, like 11-bit architecture or 360 sampling rate? Is it possible, or will that model work for all range of database, sir?
This you are talking about LSTM model.
Yes, sir. It's actually my plan is without doing the the pre-processing, directly I'm going to apply my data to the model.
Yes, people have used it. That is what is the whole claim about. I'll show you a block diagram where exactly we are now. I can perhaps answer to some extent your question. How the modern AI system, you see, this was actually the system that I was talking about. Feature extraction should be there, pre-processing should be there, right? Now,
Yeah,
what is it?
Yes, sir. Before that, I made a query. The data set architecture is about the 11-bit architecture. I mean, the ECG data signal. It is framed with 11-bit architecture with 360 sampling. 11 bits. It's about the ranges. It comes around 4,000.
11, that is there in the data set. Actually, this is recorded 360 Hz with 11 bit representation.
At the same time, if I'm using another data set, which means another database, will that model which I preferred, which I trained for the 11-bit and 360 sampling rate, will work for the another database?
It will show some result. There is no doubt. Because here the sampling rate, as I understand, is not playing much role. It should work, but how much it will work, that is, as these models themselves cannot be predicted or cannot be explained. This explanation has not come till now. So it is difficult to say. Obviously, sampling rate will have some effect. Because you know that if I sample a signal at suppose 1 kilohertz, then I am getting in 1 second around 1000 samples, right? And another same signal, if I am sampling at 200 hertz, then in 1 second I am getting 200 samples. So like you are giving input as timestamps, like suppose I am giving 2-second data into my model, right? So 2-second data means 200 are sampling frequency. I'll have to give 400 samples as input.
Yes, sir,
but if it is 1000 hertz as a sampling frequency, then I have to do 2000 samples.
Yes, sir. Yes, sir.
So that way, if you, in terms of the timestamp, if I'm using it, intuitively I can say that there should not be much difference in terms of result.
Okay.
But in terms of samples, if you are giving, suppose 200 sample I will give as input, right? So obviously in one case, 1 second information you are giving as input, and in another second, 1/5 of a second you are giving as input. Obviously the input is different.
Yes, sir. Yes, sir.
So that's how the results will be different. This is very vaguely I am talking actually to answer your question. Yes, what?
Okay. Then how about that data structure? It's about, I'm speaking about 11-bit data. It comes around 4,192. It is about the resolution what I'm speaking. If it is a 11-bit, if I am applying the same the data signal, the ECG signal for the bit of 8-bit, what will happen, sir?
Okay. So you know that if 11-bit and 8-bit, or if I'll go for 4-bit, The difference is in terms of the quantization error, right?
Yes, sir.
Now, if there is a peak, imagine there is a peak in the signal QRS complex, right? That peak. If
Yes, sir.
suppose this 4-bit representation has not captured, has missed some information, it can only
Yes,
miss
sir.
a peak. So it amplitude value only, it is the error is there. Like the number of bits, actually the error will come in terms of the amplitude value, right? Like
Okay,
if that peak amplitude is missed out in some way, that information in 4-bit, then obviously my information is lost from at the beginning itself.
yes,
So it will have some effect. But
I
sampling
think-
frequency is a different thing. Sampling frequency means if there is a information, correlated information in the time domain.
Okay.
So if I'm taking a less sampling frequency means very less sampling frequency compared to a high sampling frequency. And if that correlation is present in a, because correlation has again a time domain effect. You know, that correlation, when I'm trying to find out, it is a time domain effect. Like maybe if I'll take a very high sampling frequency, sample to sample correlation may not be there, or completely they may be correlated. After some time, the correlation will start changing. Now, this sampling frequency will have an effect on capturing the correlation structure. Whereas the number of bits will have a relationship in terms of if there is a peak value, that amplitude error may cause some missing out some information, then it's a problem. So already
Yes,
people
sir.
have
So
used them for a long time.
Yes, sir. Yes.
So there should not be, we don't bother about much about these things because these are, we assume that these are recorded with complete information.
Okay, sir. Then I need another information. What does it mean 1D and 2D? Now, what is the necessity of converting 1D into the 2D?
One,
One dimension and two dimension signal.
not necessary, because that earlier was asking me, he wanted to use a CNN model.
Yes, sir. Yes, sir.
And CNN model are more designed. Of course, one-dimensional CNN models are there. Their standard things are designed for images.
Okay, sir.
Because they are designed for images, we have to give the input as an image. That is why he is converting the speech signal to spectrograms and giving them as input. So these are like image inputs it is going. If you use one-dimensional CMN, then directly signal samples you can give. It's only thing is that spectrogram means we look at the signal in a time frequency representation. Now, if sometimes that helps us, but from the processing point of view, if it helps you, like the existing CNN models, you can use them, then that's all right. Right.
Okay, okay, okay.
Specific to the application, it can be there.
Then another question is that we can able to predict the cardiac disease by utilizing the ECG signal as well as the phonocardiograph signals, I mean the heart sound. What is the format of the signal which is stored in the database? I mean, I just want to know the PCG data information. What is the format of the PCG data set to be stored in the database? What is the format? What is the structure?
Then are you recording PCG signal?
Yes, I am speaking about sound signal.
Right. Are you recording yourself?
No, so I'm not recording any signals. I'm using the database to detect the cardiac diseases and cardiac vascular diseases by using those signals like ECG and the cardiac, I mean the PCG signals. But
Like
ECG signals, I know the structure, I know structure and properties and characteristics and the principle of that ECG signal. But I'm not familiar with the ECG signal, that sound signal. How it is stored in the database?
No, actually, I am getting 2-3 questions from your here. So perhaps your question is that from the sound signal, heart sound signal, can I find
Yes,
out
sir,
the characteristics what we get from ECG signal, like the diagnostics that we get from ECG signal? Can we get it? Is it your question?
Actually, as per my concern, we could be able to detect any kind of the cardiac diseases by monitoring the peak value, which means the R value in PQRS value. If we find the QRS value, automatically by using that Pan-Tompkins algorithm, we can find out the QRS, in which we can find out the R value also. By monitoring that R peaks, we could be able to find out the maximum, the maximum range of the cardiac diseases. My question is, how do we find out the cardiac diseases by utilizing the heart sound signal?
Yes, that's what I am saying. Okay, I got the question. So, what you want from the sound signal? How can I find out what I am getting from an ECG signal, right?
Exactly.
How the similar diagnostics I can find out from the heart sound signal? That is the question,
Yes,
right?
Yes, exactly.
Okay, you know that heart sound signal is the sound signal, right? And that basically that sound is happening because of the closure of the valves in the heart.
Oh, okay, sir.
When the valves close, then valves actually open slowly and close abruptly. And because they are closing abruptly, we get sound. Like AV valves, we get a loop sound. Pulmonary and aortic valve, we get a loop sound. Like that, those sounds we can actually hear. Putting a stethoscope, we can hear them, and that is what people record. But ECG signal is the electrical signal. ECG signal is the electrical signal which is responsible for the contraction of the heart muscles, right?
Yes, sir.
Of course,
Yes,
ECG signal is the cause for the contraction of the heart muscles, and because of the contraction of the heart muscles, the valves are opening and closing, and from there you are getting a valvular sound, which you call it the heart sound, right? So with these things, I can assume that there must be some correlation. What you are asking is a very good question. There is correlation between valve, which is a sound signal, and the electrical signal of the heart. The electrical signal causes the contraction of the heart, and because of the contraction of the muscles, the valves open and close. And this opening and closing things we are recording as heart sounds. So intuitively, I can guess there must be some relationship, but people don't know till that. Only I can say. Till now, we know intuitively, because all the problems, there are actually 3 types of problems in the heart. I can say that valvular problems, like if the valves are not opening efficiently or closing efficiently, we say these are valvular problems. Second problem can occur due to the electrical conduction. This electrical signal, which is being conducted to different parts of the heart, may be having some problem because some of the high cholesterol and all, the conduction paths are blocked. So when the conduction paths are blocked, then there will not be efficient conduction of the electrical signals to the different parts of the heart. Third problem is the myocardial problem. That happens if a particular site in the heart, the muscles degrade due to various reasons, due to various pathological or old age reasons, then the muscles degrade. When the muscle degrades, then also heart problem can start. But these 3 problems, the valvular problem, the muscle problem, and the conduction problem, they are all interrelated. So if there is a conduction problem, automatically there will be a contraction problem. Automatically it will appear as a muscular problem. Muscles start degrading. Automatically it will appear as a valvular problem. If there is a valvular problem, it will be reflected in the heart sound. You see how they are correlated. Are you getting it? So they are correlated. But now people exactly do not know how they are correlated. This is there. These people, this assumption is there. We know that they are correlated. So scientifically, I can say that yes, they are correlated, but exactly this has not been found out. In fact, I am telling you, just to respond further to your question, recently analog devices in US, actually, one person visited me. He told me this is their problem they are working on, and they are trying to find out, because in future, because recording an ECG electrical signal, those who have worked on ECG signal or have ever used ECG machines, you know that the standard 10 electrodes are to be put on the body, and this can be recorded in a clinical environment only, right?
Yes, sir.
Because you need the patient to be taken to the hospital or a clinical or in a lab environment, right? But sound signals you can record anywhere. Like there you are sitting, you just take a stethoscope, put a microphone behind it, you can record this, you can hear the sound signal. So it's very easy to access for the sound signal. So what exactly people are trying, if can we do diagnosis from the sound signals, then it will be very cheap and it will be very successful for the industry. Huge market is there. But we don't know, though they are also assuming it is there. So he was talking to me, he told me that how it can be done. Some preliminary work we have done actually, we have some results, but we also don't know how it is happening. So it will be a great thing if people come to know exactly how, then the thing diagnosis will become very easy. Those who have worked on ECG signal, they know that ECG signal acquiring itself is a much more complex situation compared to acquiring a heart sound signal. Sound signal nowadays a lot of sensors are there, na? These earbuds and all the microphones are there. We can record these sound signals very easily. So if from the sound signal, if you can diagnose, this will be an end. Definitely, I'm telling you, in 2-3 years time, you'll see the product in the market. Because already big companies and research lab, they have focused onto this problem. This will be solved in no time. And my prediction is that in 1 or 2 years time, you'll see the solution. And slowly, maybe ECG signal may go out of market. And all diagnosis will happen based on the heart sound signal, because it is easy to acquire. It is very cheap to acquire compared to an ECG signal. We don't know how the science will progress, but this problem, at least solution is in the, I can say, in our sight. Solution is there. We don't know exactly how it is. All right.
Thank you. Okay, sir. Thank you, sir.
If you are attempting this problem, this is a nice problem to attempt.
Okay, sir. Thank you.
Okay. Any other query?
No, sir. No further question, sir.
Yes.
No further question, sir. You may continue.
Okay. In fact, these questions are better than presenting you the things. Anyhow, now coming to, for those who don't know about the heart, heart is located on the left side in the thoracic cavity, right? Mostly 2/3 of the heart like located on the left side. Just 1 minute. Let me go to the presentation mode now. So located in the thoracic cavity between the lungs in the mid-ostium. 2/3 of the heart is located on the left side. Its apex or concept and rest on the diaphragm. Average weight is 300 grams. Of course, 1 in 10 million people heart located on the right side. All of you should check where is your heart, on the left side or right side. I know some people heart on the right side. Because unless you know it, sometimes in the medical condition, because paramedic staffs record all these things, they may get panic because they have standard way of recording ECG signal. Those standard machines, when they put on recording your ECG signal, and if the heart is on the right side, this actually assumes heart is on the left side. But 1 in 10 million persons heart is on the right side. So you should check where is your heart. And these are things that you know. We have actually 4 chambers. Upper 2 chambers are called atria, lower 2 chambers are called ventricles. We have atrioventricular valves which regulate blood flow from atria to ventricle. And we have semilunar valves located basically between the ventricles and the aorta, and left ventricle and aorta, and right ventricle and the pulmonary artery. It is a pulmonary valve. So this is an internal picture. On the right side, this is the tricuspid valve, and this is the bicuspid valve on the left side. So the electric, heart is an autonomous organ. Why you say autonomous? It has its own electrical system. It is normally not controlled by the central nervous system. If you take out somebody's heart, put it in the saline water, it will keep on working. Because it has its electrical generator that is at the sinoatrial node on the top of the right atrium. The sinoatrial node is there. From where the electrical signals, when we are in the mother's womb, from 5th to 8th week of pregnancy, almost from the 5th week of pregnancy, the heart starts functioning. When nothing in the body is created till that time, the heart is the first organ to start functioning. Once the heart starts, that's why actually in some Indian scriptures, they say that heart is the seat of your soul. And when the heart starts functioning, the soul enters into the body. These are there in our scriptures. And we are not sure, but we cannot disbelieve also completely, because the heart is the first organ to start functioning in the body. And we are only in the 5th week of pregnancy. And then the rest of the body slowly is created. And at the sinoatrial node, the electrical generator is there, which actually produces impulses at 72 beats per minute, like at an average heart rate if I'll take. And the impulses are conducted at different parts of the heart through a specialized path. These green things are the electrical conduction path. So the impulses first reach the atrioventricular node. From atrioventricular node, it goes to the bundle of each. Now there is a delay here of 130 milliseconds. You know, typical heart rate is 72 beats per minute. So it is almost like if I take 60 beats per minute, that is almost beating at once in 1 second, right? 72 beats per minute, if I'll take, it is actually 800 milliseconds is the duration. And out of 800 millisecond, 400 millisecond is the electrically silent period. And 400 millisecond, all activities are there. So there is a delay of 130 millisecond is there for the electrical impulses to pass from the AV node to the bundle of His. Now this delay, nature has produced it because what is this electrical signals do? When these electrical impulses spread to different muscles, our biological muscle has a property. If you give an electrical impulse, it will contract. So these electrical impulses, as they spread into, and they are very high amplitude signal, 125 millivolt signal. And when they spread onto different parts of the heart muscle, the muscles contract, and that's how the pumping action takes place. Now it is required that the upper two chambers must contract first before the lower two chambers contract. So the blood should come efficiently to the lower two chambers, then the lower two chambers should contract. So this is a coordinated action. So for this to happen, nature has produced a delay circuit here. Very nice delay circuits are there, where the electrical signals from the AV node to bundle of His, that means towards ventricle, there is a delay of 100. In electronic signal, this doesn't happen, but these are all ionic signals. And then through the left bundle of His, right, it goes to the apex of the heart, and from there through Purkinje fibers, it spreads to different parts of the heart. And this one is you. This is a figure that I have taken from a physiology book, Guyton book. This is how the different signals are correlated. This is the ECG signal, electrical signal, which is responsible for the contraction of heart muscles. Now, as this P wave, as this signal comes, like the P wave, we get it during the contraction of the upper two chambers, the atria. This QRS complex, the big, you can say amplitude part, that actually appears when the ventricles contract, and T wave when the ventricles relax. So, you know, when the ventricles contract, then what will happen? The lower two chambers are contracting, upper two chambers are relaxing, then the AV valves, atrioventricular valves close because of the back pressure. And that is where you hear the first heart sound. And then when the ventricles relax during the T wave, then the semilunar valves, that the aortic valve and the pulmonary valve, they close. That's why you get another sound called S2 sound. So the first sound appears during the closure of AV valve, and you can see how they are correlated. This electrical signal is responsible, QRS complex is responsible for contraction of the ventricles. So when the contraction of the ventricles take place, then the first heart sound is heard because of the closure of the AV valves. Then when the ventricles relax, then the closure of the semilunar valves happen, and because of that, actually second heart sound is heard. So accordingly, this is the ventricular volume. You know, so when the ventricles close, then the ventricular volume goes down. Then when they relax, again the blood comes in and the ventricular volume goes up. So this is the ventricular pressure, the red one. So if you look at this picture, you'll get from Guyton book. So how the different things are correlated. And this is basically the doctors use for diagnosis purpose. So these are the different time delays that is there for the electrical signal for it to get conducted to different parts of the heart. I think the time is getting over. I'll just go to the signal. And this is what is, if you record, this is what is an ECG signal you will get. Okay, these are the different interpretations of ECG signal. And this signal has a bandwidth from 0.5 Hz to 60 Hz. And this is what I was talking to you before. And we record it as a 12-channel signal. So recording of 12-channel signal means we are recording it from different actually views or angles. This helps us to get the spatial information about the electrical activity of the heart. And if you record 12 channels, you'll get this 12 channels, something like this. Lead 1, lead 2, like 12 leads. Anytime you go to any ECG recording system, they will always record. This is standardized ECG signal because the different abnormalities may occur or may appear in different actually the abnormality. It's compression, because we can do very efficient compression of the signal because all the timing information are same and the signal characteristic looks similar in different leads, and that is what people exploit for compression of this multi-lead ECG signal, because you can see there are a lot of redundancy across the leads, and there is a inter-bit redundancy is also there. Bit to bit, same thing is getting repeated. So that is called inter-bit redundancy. There is a intra-bit redundancy. There are a lot of correlation in the same single bit. As you can see, there are almost 400, half of the ECG cycle that is actually silent, electrically silent. And only half portion, almost nearly half portion, information is there. And this is what we had done some compression. In myocardial infarction, this is a disease actually which leads to heart attack. If there is a coronary obstruction in the coronary artery, this disease may appear. The signature in the signal will be something like this. T wave peaking like this, or this is the elevation of the ST segment, or appearance of new Q wave as the fourth one. So various signatures, pathological signatures appear as the changes in the wave shapes of this signal, and that is what exactly the doctors try to see. And we as engineers, using automated algorithms, we try to detect them for designing automated, you can say, algorithms. Okay, so anything you want to ask me? Time is almost getting over. Another 7 minutes left. It is better let us discuss something. Anything you want to know about ECG? ECG or diagnostics? Yes. Yes, any query? It will be nice to have whatever may be you may be hearing the ECG signal for the first time, but still if you have any query.
Sir, one question is there.
Yes, yes.
Sir, am I audible?
Yes, yes, yes.
So my question is, when we go for wireless acquisition of ECG signal, we have more noise compared to the standard one. So how you will be processing the signal, especially in noise removal part?
Now, have you yourself recorded anytime wirelessly?
Yes, sir.
Huh? You have recorded?
Yes, sir, I have recorded.
What type of system you are using for recording wirelessly?
Commercially available sensor, sir.
Now, can you tell me the machine name or which brand, which company's machine you are using?
Say the 8232 sensor.
Yes.
So with that, I'm acquiring ECG, sir.
No, exactly. I'm trying to find out, when you're saying wirelessly you are recording, what type of machine you are claiming that you are recording wirelessly. Then I can discuss the type of noise that you may be coming across.
Not completely wireless, sir. Like I'm connecting with my laptop. My plan is to make it a wireless one. But even though when I record with the sensor, we have more noise, like motion artifacts are there. So how we can eliminate those noise, sir?
What type of noise you are getting? What type of noise? Basically, is it a Bluetooth connection you are doing it? How you are connecting it wirelessly?
With a normal electrode.
I think Dr. Anurag, you can ask her exactly what is exactly the device that she is using for wireless connection. Actually, sometimes
I think,
nowadays
sir,
ECGs, Apple Watch and all, they are recording. This is not wireless recording. If you are meaning by
Sir?
that Apple Watch.
Sir, I think she is not using any standardized machine. She is just trying to create a system like using existing ready-made in the market. There are sensors, CCG sensors are available nowadays. So she's just trying to make a device for acquisition wirelessly, and through that she is recording. So obviously
What
it will
device?
not.
It is no, what device? Is it Apple Watch? Apple Watch type of device? Or she is putting electrodes. There are two things. Really electrode, putting the electrodes and recording the real recording of ECG signal. If you are using devices like Apple Watch, nowadays this watch are there, where they show that ECG can be recorded. These are not ECG signal. These are not ECG signal. They actually derive ECG signal from some other area. ECG signals are directly electrical signal recorded through electrodes, right? And then wirelessly they can be transmitted, the machine that we are using. But another thing is that what these Apple Watch type of devices, they claim they are not actually electrical signals. They are actually recording, suppose PPG signal and converting through some, I can say loosely, using some empirical formula, they are converting those signals to an ECG signal. And
Sir, actually, sir, sorry to interrupt, sir. Sir, actually, what she is using actually nowadays, sir, there are Texas Instrument many A to D converter, ready-made ADC converters are available specifically for ECG. So AD8232, that is, I am also aware that is usually from Texas Instrument that is available for specifically ECG. So I think that is he is using to acquire the ECG, and after that she is making some connection, manual connection from her side to record in her laptop. So there in that environment she is recording, not using any sophisticated or ready-made devices which are available in the market. So in that perspective, she is getting obviously motion artifact and other type of noise she is getting. So see, sir, her question is related to that, how to address those things.
Okay. So it all depends. Anurag, you can also explain her. It all depends the type of noise. If motion artifact is a low frequency noise, right? And if you are getting, suppose, high frequency noise like the Gaussian white noise as we get it due to electronic, basically the device involved in recording or in receiving the signal, then it's a high frequency noise, or I can say white noise. Not for high frequency, it's a technically, the flat spectrum is there. So depending on the type of noise, you can use the filter for pre-processing. Now, if you have a signal, you can, I'll request you to show it to Dr. Anurag. He himself can suggest you. The type of noise, unless I see the signal, we cannot suggest exactly. Difficult for me to suggest. But depending on the type of noise, we can, like motion artifacts, most of the time are actually low frequency noises, right? And if we are recording an electrical signal directly from the body, then the motion artifacts may appear. But if you are converting a signal like this Apple Watch and all, that is not an electrical signal, the motion artifact you will never get. But other electronic noises, because you are using some A to D converter and all, you may get the noises which you can eliminate using a low pass filter. Those mostly the content is high frequency. What type of noises you are getting? Characteristic of the noise?
A baseline monitoring and EMG signal is also there, and especially motion artifact.
Motion artifact. Okay, motion artifact. Depending on the motion artifact, obviously you expect the patient to be stable, right? If the patient is stable, not motion artifact, muscle artifact, right? If the patient is stable, the muscle artifacts you won't get. But if the muscle artifacts are in which range, if they are completely overlapping with your, suppose, QRS complex, these are impossible to handle. There is no particular algorithm is there because they are completely corrupt. So we, while recording muscle artifacts, directly we try to handle it, somehow making the patient stable. Because if the patient is not stable, suppose he is moving, he is in an uncontrollable state, then muscle artifacts are difficult to handle. So the only solution is that to make the patient stable, right? But yes, motion artifacts most of the time, because any unintentional movement of limbs and all, then motion artifact may appear. If they are not overlapping with your completely QRS complex, you can easily eliminate them using high pass filter or an adaptive filter. You can handle them. Looking at the signal only, one can comment. Otherwise, you can take suggestions from Dr. Anurag. The type of artifact, based on that, you can think of.
Yes, sir. We will see and answer that query. I see having another query, sir.
Sir, can you just tell them methodology which you followed? As you showed, like in your lab, you had a wireless ECG sensor you were placing on that. So can you just tell me what the processing you done for the signal and how you got the ECG signal?
No, we don't require any processing. This device actually, you know that maybe this was the picture I was showing you, na? Wirelessly we are recording it. Wirelessly we are recording it. So we don't require any signal. We get completely. This is a completely standard machine we have taken, and we don't get any noise, because here you can see the person from whom we are recording. He is of course one of our research scholars. He is stable, so the muscle artifact will not be there. And the sensors and the system itself, there won't be any hype. Nowadays, the hardware is so robust, standard hardware. You won't get also those so-called high frequency noises and all. That also will not appear, because the sampling rate itself is very low. Because the ECG signal, you know that 60 Hz is the bandwidth. So hardly with 200 Hz we get it, and most of the noise are beyond that. Most of the time. So, and immediately as we record it, they use a low pass filter up to 60 Hz or 100 Hz. So once you use a low pass filter of 100 Hz, whatever the Gaussian noise or your instrument noise, everything will get reduced. I mean, technically speaking, not completely eliminated, but they won't be visible. Like if you go to these commercial machines, whatever this strip chart recorders they in the hospital they use, you know that the low pass filter they use at 30 Hz. Up 30 Hz mein, there won't be any noise, will not be visible. And above that, if it's a mechanical device like recording it with that pencil movement, pen movement, then it has a very low frequency response. So where this high frequency noises will not be visible. But if there is a muscle artifact, yes, that will appear obviously. All right. Depends on the device. If you show the signal and what type of noise, we can guess and we can reply.
Question? Further question?
Any other query?
No, any query, sir, for this.
And then I think Dr. Anurag, time is over.
Okay, sir. Okay. Thank you, sir. Thank you very much for this insightful discussion. I hope everyone has got something of their interest. Obviously, the way we planned it went in the same way, and I hope hopefully it will help everyone in some or other way in their respective research efforts. Thank you, sir. Thank you very much for joining us. Though we expected you to come physically, but somehow it couldn't happen. We expect you, sir, next time to present here physically.
Thank you for patient hearing. I hope some queries I could answer. Thank you all. Thank you. Thank you, Anurag. Bye bye.
Thank you very much. Okay, sir. Thank you. Yeah, I think.
Okay, because the port is not there.
So both are required simultaneously.
Yes. No.
Simultaneously, if required, man. Okay.
So if you have any query right now,
Yeah.
you can
Just-
interact. You can utilize the time.
To have, from Professor Dandapat.
Morning session. Yeah.
He has very good facility for understanding.
Yes. This one.
In his laboratory, IIT Guwahati. And actually, these days, students they take a lot of interest in recording the data. Time is changed. Earlier, students were not showing interest. These days, students are very innovative. They are very like they want to do practical work and they do a lot of recording. Because this generation is habitual with the mobiles, smartphones, so they are very comfort with the machines. Our time actually used to be distance. The difference. The students do sort of work, such kind of work. My students go to hospital, they record data. They're using
Especially, I think.
this open angle glaucoma, that is actually large number of cases. And closer angle glaucoma, there are very less number. But in India, it is opposite. We also have more number of closer angle. So this our student, they recorded data and they found statistics. They got best paper award for that paper in Russia. And the first time they reported statistics. So we are just following actually blindly Western and USA. Our people are different. We are different. Our eyes are different. USA people eyes are different. Our fundus images are different. Now it should it should be done on Indian.
Pointer.
And once vision is lost, then nothing is there. Vision is very lightning. This is actually our public databases, but we have studied on own database of Indian database. That I have not done. Because this comparison with other existing methods is still the same database, but we have our own database. We have very good hospitals in Indore. We are collaborating with them. Even these the doctors are also taking interest in research. Slowly, things are getting
After connecting
Yes, this is medical professors. They are actually a part of hospitals and they are also professors. So such kind of doctors they do research, they take interest. And not only just for clinical, they also work somewhere as a medical college.
Okay. हाँ पॉइंटर वही है सर अभी आगे this is Yes, this is so one click. One click. Sir, one click में change हो रहा है महफूज sir.
ठीक है जो है
Yeah, this is laser. नहीं, मैं laser
प्रेस करके
हाँ, laser is like this.
this one
हाँ. Sir, previous. Pointer.
previous
Previous कैसे जाएं?
previous तो ये
Pointer sir, top one.
this is the next one
Yeah.
fine
Laser.
This one is for laser.
Sir,
very nice it is fine I think this what is actually there is a like saying that when you smile then good photo comes and if this is for just one instant if you smile always then actually entire life can be better so like for one time if you smile then good photo comes then it's life is like a set of images the video so if you smile always then entire life can be better it's like entire video will be better.
now
Hmm.
everything is fine.
It's good. So smile is also actually three types of smiles. But this discontinuity has been created, so it'll go just smoothly. If you like smiling, laughing, there is also three types. If you laugh on other, there is poor laughing. And if you laugh on yourself, then it is good laughing. And if you laugh without any reason, then it is accident laughing. So actually, we should know how to laugh without any reason. Then actually you are already at a higher level. That you don't need any class. Is already that is actually supreme level. That is laugh. That is laughing without reason. That is actually excellent laughing, and it is saying if you can laugh loudly, this means that you don't have heart disease. And if you are not laughing loudly, this means you are inviting heart diseases. So laughing is always good, and laughing not like laughing silently or saying it should be like loudly, like with like everybody will see that you are laughing. So that is actually very good for health. So whatever tough time, bad time, whatever good time, we should always keep laughing. That is important part, and is good for health. So now we have seen this this glaucoma. They actually there is mainly two types. One is open angle glaucoma, and second one is angle closure glaucoma. So this is the common types of glaucoma, open angle, and symptoms cannot be detected early and develops progressively, slowly, and this is due to insufficient drainage of fluid out of the eye. And if it is not detected in early stage, it can cause gradual loss of vision. So like you have seen most of the cases, we have this open angle glaucoma. And in this work, we have studied open angle glaucoma. We have also studied closer angle glaucoma, but not included in this presentation. Angle closure glaucoma, it is rarely found and also known as narrow angle glaucoma. And this is due to sudden blockage of a drainage system of eye and results in acute pain, red eye, and immediate loss of vision. So and in India, we have actually a large number of this kind of glaucoma. In USA, we have more large number of open angle glaucoma, and there is a lot of focus on study of glaucoma because there are many cases for this open angle glaucoma. But in our case, actually both are important. So we are focusing on this angle closure glaucoma also. Many old people, they become actually blind. So lot of actually study has been done in the literature, and there are like we will see some major study for this glaucoma diagnosis. So Nayak and others, they diagnose glaucoma by extracting features like CDR, and many people they use signal processing also, and the CDR, this cup to disc ratio, the main features, other features also, like the doctors, whatever doctors see, these clinical features and also signal processing based features. So we combine both of them. So here like this work, this is CDR, distance between optic disc center and optic nerve head, and INS2 rules. So these all whatever doctors actually they use, and that actually Naik and others they use artificial neural network, and they in 2009 they classified this glaucoma and based on fundus image. And same reference to they actually pre-process image by correcting illumination and removing blood vessel. So after pre-processing, they compute spline coefficient, Fourier coefficients as a feature, and then support vector machine classifier used, and they detected the glaucoma. And the reference 3, radon transform and higher order statistical features have been computed, and this Bayesian classifier is used for this automated classification of fundus images. And last fourth reference, they use CDR compute ratio and anisotropic dual tree complex wavelet transform features. So this is like this is also like images we want to have phase information. So this is we use 2-channel wavelet transform, real part, imaginary part, that that is dual tree complex wavelet transform, and with the MLP they actually classified this glaucoma. Acharya others in reference 5, they applied Gabor transform on image, and from the Gabor coefficient 23 features they extracted, and then applied the support vector machine classifier. And so you can see in most of the like papers, people use signal processing, modified census transform, complex wavelet transform, and then they actually use various classifiers to detect this. So most of the cases there is a study signal analysis classification. So there are 3 important part of this automated system when you design. One is image analysis, and second one is feature, and third one is classification. So any of the part actually you can make contribution in order to have like a significant work in this area. You can come up with a new image analysis technique, you can come up with the new features, you can come up with a new classification technique, and even like you can combine these 3 things for the first time in the literature for this application also. So now we will see our this 2-dimensional Fourier Bessel series expansion based empirical wavelet transform based method for this computer aided medical diagnosis of glaucoma. So it is the extension of the Fourier 0 order or first order FBSE that yesterday we mentioned. So this work actually presents two-dimensional FBSE WT method for image analysis, and 0 order and first order. This 2D FBSE WT has been actually they have been studied here, and then we have also proposed them using multi frequency scale. So this empirical wavelet transform is defined as the full scale of the spectrum. But then when you have said different spectrum, actually different scales, then you can get different kind of information. That scale is very important. So whatever actually signal image you see, they are arranged like onion. So you remove different layers or different layers of the onion, you will have different information. So this scales gives you the different kind of actually information, like zooming kind of phenomenon. So you have half scale, this like entire half region you are looking at full scale. You have seen like when you apply for some application like job or this for some application, then they ask for photo, and you send your photo of the face, not your photo with your bangla. What is the reason? Suppose I will you send your photo with your house, then can I identify you? No, because house scale is different, your scale is different. So we need actually we are interested in your information, your identity information. So we always put the space, that scale. So you cannot like, so that scale is required. Similarly, like there is one of the strong group on wavelet that is EPFL, Lucent. And actually Lucent, Switzerland, people go for tourist, and that group has understood wavelet in such a manner, they have put zooming cameras. So like at different scales, you can see different information. So like if you some scale, you can see the France, at other scale, you can see the Switzerland, and other scale, you can see the sea between Switzerland and France. And at particular scale, you can see all of it. So that is actually, so different scales give you different information. So motivated by that, we have also proposed this multi-frequency scale framework so that you can get actually different scales and corresponding to that different informations. And we don't know which scale is good for medical information. So there have been two actually like different kind of this classification frameworks. One is simple machine learning based methods, conventional, and second one is very popular these days, convolution neural network, deep learning CNN. And here actually we have studied both. And for biomedical application, this actually conventional machine learning methods actually are very useful because you can extract the features, and then features you understand the insight of the data, insight of the disease, and then you can give them as input to classify. So like it is like explainable AI. Signal processing part actually plays important role. So whatever features you extract, you know about them and you understand them, and then actually in convolution neural network you can classify whether you have disease or not. But in conventional machine learning algorithm, you can actually correlate the features with the disease, so they are more meaningful. So in biomedical, we actually always prefer to go for conventional machine learning algorithms instead of this CNN, because you can correlate the features, and feature itself can be used as a diagnostic feature. So how to apply this FBS EWT for this image? So we actually compute average row and average column FBSE spectrum. So we have image like this. So we apply FBSE row wise, and then we actually average each column. So in that way we get the average row FBSE spectrum. And second case, we apply FBSE column wise, and then whatever resulting image is coming, then you average row wise. Then you will get average column FBSE spectrum. So we require actually two FBSE spectrum, and once you have these two, then we actually apply this order 0 and order 1 FBSE expansion. Yesterday we have seen. So this is the analysis synthesis expression for 0th order FBSE, the synthesis expression for 1 order FBSE, and these are the actually Fourier Bessel series coefficient for 0 order, and these are the Fourier Bessel series coefficient for the first order. So from that we can compute, and once you compute these coefficients for this row wise, column wise, and average row spectrum, column spectrum, then perform boundary detection on this column spectrum and average row spectrum using scale space approach, and build corresponding filter bank. So scale space approach, in this actually we consider spectrum as histogram, and this is in this spectrum indicates occurrence of particular frequency within the signal. And then scale space operation is like smoothing and with this Gaussian filter. So this is actually scale space, and then this filtering, this Gaussian filter, that actually this C is important parameter, and this M depends on the this parameters. So here we have taken actually 6, and on smooth spectrum boundaries, we are detected they are using maximum minima approach, and it's minima between 2 consecutive maximum. So here you can see this is one toy image. It's actually standard image for this study in the paper, that EWT paper for images. And you can see here, this is the actually average row spectrum, and here this is average row spectrum using FBSE method. So which one is more detailed, using this Fourier transform, this one, or using this Fourier Bessel series expansion? Which one is more dense? Fourier Bessel series expansion. So here you will get actually many components when you perform the boundary segmentation of the spectrum. Here you will get only few components. So that is why actually FBSE is very suitable for image. Even it is better than one-dimensional signals. So we have observed nicely. You see a lot of actually nice dominant components are there, and you can separate out the intrinsic mode function IMS from this design filter bank. So from this we design the filters, and then from the filters we separate out the subband images. So here actually similar to this wavelet transform, like when you go for second level discrete wavelet transform, then we get approximation and two details. When you go for fourth level DWT, then you get four details, one approximation. So here the approximation is represented by this wavelet, that is empirical scaling function, and the details are represented by this mathematically. So that is actually empirical wavelet function. So we can use this as a basis functions to represent approximation details, but they are actually adaptive way they are designed. So you are applying this after segmentation, you have boundaries, and each boundary for low frequency component, we use the first one, and for the high frequency components, we use the all this one. So where this function, this is Meyer's wavelet, that is actually defined this way. And, we want to have a tight frame. So like this basis one tight frame means they are orthogonal. So like sometimes wavelet we also have frames. Frames like they are more general conditions, like they go more redundant. You can have more number of basis functions also. But here, in order to have orthogonal basis function or tight frame, we ensure this condition. So that if you satisfy this condition, then you have perfect orthogonal wavelet transfer. So now we will see some results. So here actually this fundus image, after this first one is the RGB image and second one is green channel, and this is pre-process. So in the literature, actually, it has been shown that green channel is highly suitable for the image biome, this fundus image classification. So they studied RGB and they found that green channel also like it is always found to be good to see the green things, like it is exercise for eyes. Morning get up and you should see the green trees, green things, that is actually considered. Many people use green paints in the house, so always they see the green. So that green is like exercise for eyes. And luckily here also we have got green channel as a like it gives you better performance. So now here you can see for green channel, this is the pre-process, and here these are the first two. They are the zero order FBSC expansion, average row spectrum and average column spectrum. And this is for first order FBSC. These are average row spectrum, average column spectrum. And these are the design filter banks. So here you can see this filter bank for average row spectrum, average column spectrum for zero order FBSC. And this is for average row and average column FBSC spectrum for first order FBSC. And then from this, we have actually the number of boundaries that you selected is one, only first one. So the number of subbands will be, suppose you are selecting n boundary, then n plus 1 into n plus 1. So now here you are using boundary 1. So there will be 4 subband images. So this is using zero order FBSCWT. There are 4 subband images and for this fundus image. And these are using zero order FBSC EWT. And this is the case of one order FBSCWT. So in different like zero order, you get these 4 subband images and using only one boundary, first boundary. And this is using first order FBSCWT. Now this is average row spectrum, and here actually we have shown this for full spectrum when you are using full spectrum, and this is for half spectrum, this is for quarter. So in all cases you can see here we are having filter bank for all frequency components. Here we have filter bank only for half frequency scale. Here we have filter bank only for quarter frequency. But in all cases, you see that when you apply algorithm, then you are here you have more dense filters. Here you have less dense. Here you have more like less dense compared to this. So actually, it helps us to have different resolutions at different scales. So this all these three key scales, full scale, half scale, and quarter scale. These are the subband images. Often 4 subband images. And these are the 4 subband images for quarter. This is half scale, and this is for quarter scale. And that you can see. So all the 3 cases, these subband images are different, and we want to see which scale is better for this diagnosis of glaucoma. So this is the proposed method first, where we are using conventional machine learning approach. And here you can see this is the green channel. Then pre-processed it. Then this is a pre-processed green channel. Then this apply two-dimensional FBSCW method and extract the features. Then select the significant features. Then apply classifier. Then you will classify into healthy and glaucoma types. So for this study purpose, we have taken this database. These all are publicly available databases. RIM1, RIM1R2, RIM1R3, Drishti GS, Origa, and they have different number of images for glaucoma and healthy. So total images also you can see this table. And for feature extraction, we have actually like the GLCM, and then histogram features, and they are and movement inversal movement based features. These all are total 116 features have been used for actually capturing the information of this fundus image. Yeah, this is already existing, but it has been studied for like face recognition, not for this glaucoma. This energy. Energy. Yeah, actually in it's very good question. Actually, the question is why we are taking energy? Why we are not taking here 3, 4, 5 like this? Like mean square error when you compute, why only mean square error? Why not 5 power 5? It's a very good question actually. And this in actually images there is no such answer, but when you see the signals we consider as the output of the system, and energy is the amount of the work which is required by the system to generate that signal. So like suppose you have one signal which is existing from minus infinite to plus infinite. What is the energy of that signal? Can anyone answer? If signal is existing from minus infinite to plus infinite, sinusoidal function, this is periodic function existing from minus infinite to plus infinite. What is the energy of this function? Without calculating any formula, then we will understand physical interpretation. Yeah. It is infinite because we have to do infinite work to generate that signal. So this energy is the amount of work which is required by the system to generate that signal. So it is actually energy is connected with the work and with the system. That is why always whenever we take the signal, there is a presence of the system from which that signal is generated. So energy makes sense because this energy is the amount that is the amount of work to generate that. You have finite energy signal. This means you have to do finite work by the system to generate that signal. And motivated by that, similar way, this we have defined for image. This is actually for one-dimensional signal. It makes sense. There is causality. Causality makes sense in one-dimensional signals, but in image there is no time. It's static. It's a spatial domain. But here, motivated by signals, we develop theory for images. But image, there is no time in the image. Image is just photo. But still we consider like a spatial domain, x-axis, y-axis also like time. And we apply transformation. Like in yesterday you have seen signal was a function of time. But here it is image and we are applying FBSCWT. But two-dimensional. So we are considering that x-axis as a time, y-axis also time. But it's not time, this is spatial. Time will come only when you go for video. Then image will be function of time. So these are actually motivated by this one-dimensional concepts, and that actually like image is just like a matrix. But based on the intensity variations, people have also interpreted them in terms of signal. So intensity is also changing with respect to two independent variables, that is x-axis and y-axis. So they consider like a 2D version of this 1D, like a signal. And AC Bobbitt actually was the first person, and he represented image in terms of non-stationary signal decomposition methods like AM/FM signals, AM/FM. So like non-stationary, he also represented this image in the form of non-stationary models, AM/FM. Like the one-dimensional we have seen, here also two-dimensional AM/FM. So your intensity is also changing, and its frequency is also changing. So he has used this fingerprint for AM/FM model. So like there is a nice intensity variations. So this that is why we always take mean square error. We absolute error. This all this data science people they take absolute error also. But signal processing person will always take mean square error, because that error, in terms of error, you are defining the signal, its energy. So you are saying that when you see the difference of these two signals, then there is no requirement of the work. That is nearly zero. So this means two systems are doing similar kind of work to generate the signal. So that difference between the work is the same work. So the two systems are like actual signal, reconstructed signal that is generated. We are assuming that is also generated by the system, but both are doing same amount of work. So error is nearly zero. These are actually definitions of English, but sometimes there are good definitions in Hindi. What is force? How do you define force? Like this is the energy is the amount of work required by the system to generate the signal. What about force? Bal. Bal. Force. हाँ हाँ हिंदी में बताइए. Please wait. बल वह बाह्य कारक है जो किसी की वस्तु की अवस्था में परिवर्तन कर देता है या ऐसा करने का प्रयास करता है. That is force. So such definition you will not get in English. So sometimes mother tongue is always good for long term. Important. English, you will find actually research has been done. Those people have studied in mother tongue, with their mother language, their medium, like even Hindi, Marathi, Tamil, Telugu, up to 10th class. Their English have been better. Is better compared to the students who have studied English medium from the beginning. You can be the topper, you can get good rank, but when you come for the thinking process, then it will actually they will be better. Those who have studied in mother tongue, always better, because you can understand concepts in your own language. Mother tongue means mother has taught you. The mother is the first teacher, and we learn from the mother, and that language is your actual language. So that is why we call mother tongue. What is neural network? See, and this is all like already we are starting from the mother. Mother is the first teacher. She teaches, is the person, this is the family members, introduces with everyone. And after that, we don't ask mother. We learn it. The training is done. And after that, we automatically we say his uncle, auntie, even father. Everybody actually introduced by the mother. Entire world is introduced by the mother. That is supervised learning. And after that, we do independently. That training is done. So now you are doing testing. So this is the actually this all concept they have come from This one-dimensional signal energy. So all are actually this Newton's law. कोई वस्तु अगर गतिमान अवस्था में है तो गतिमान अवस्था में रहेगी, कोई वस्तु अगर स्थिर अवस्था में है तो वो स्थिर अवस्था में रहेगी जब तक कि उस पर कोई बाह्य बल आरोपित न किया जाए. वेरी गुड डेफिनेशंस. किसी भी वस्तु को द्रव में आंशिक रूप से डुबो जाता है या पूर्ण रूप से डुबो जाता है तो उसके भार में कमी आ जाती है. भार में यह कमी उसके द्वारा हटाए गए द्रव के भार के बराबर होती है. These all are actually very nice concepts. Archimedes Siddhant that you can always remember. हाँ. Yeah. It's all actually, these all things are connected to each other. When you do research, that's why researchers, they always, everything like, for them, everything is connected. You can get idea anywhere. Things, all concepts, whatever, this is also there, but in different way. Everything is existing in the literature and we are just exploring. Even children also know the Newton's law. 2 years old child also knows the Newton law. He will put his toy in some almirah and morning he will get up and he will go to that place only. He knows that this toy will not move to other almirah. So this means he is aware with the Newton's law. That whatever, wherever he has put that thing, all family members know the Newton's law. My mother also knows. She has put something in almirah. Next day she will remember that I have put there. I will find there only. So everybody knows. This is just science, is just to explore that. Before Newton's law, also people are using Newton's law. So every things are there, but just exploring it. Even you children, they know more science compared to us. When you become like grow, then you are limiting yourself. They learn from everyone. For child, everyone is same. They interact with everyone, and when you grow, then you limit yourself. This my class is this only. I am higher class person. I will interact with these people only. So like limited, focused. I think it is going in other. Just a focus is started. I will one my personal observation I have seen. Most of the boys are unfocused, and most of the girls are focused. That also increases with age. If you see 70 years old woman, grandmother, she will be always worrying about her family. And if you see 70 years old grandfather, he will be always worrying about others' family. See what he's doing, how much he has grown. Like grandmother will always say like you focus on your work, you just take good food, be healthy, that's fine for us. So that is actually focus in cases. So even in family itself, we have uncertainty principle. One kind of people, they are focused, other kind of people, they are unfocused. So that nature has given such kind of input. So here these are actually features. It's clear. Right. So after that, these are movement inversion, like movement based features, and then these features are based on histogram. So like image histogram, and then you can compute these features. So after that, these features, all features are actually not relevant. So there are only some features are statistically significant features. So there is a principle that is known as parsimony principle. Parsimony principle says whatever is required for the model to represent the data, you should not take more than that. For example, if you need 5 chapati, then you should not ask for 6 chapatis. This is parsimony principle. So parsimony principle, if you want to study, then you should find the significant features. So actually, here you can see this is for zero order, the BSEWT. And this is, I will not call 2D because this is 2D in that presentation. And this is for one order FBSEWT. So here you can, this all three databases, and this you can get 90%. Just take nine principal components. Here, if you take 13 principal components, then you can get 90% variance. 90% of the energy of the data is preserved. And then this performance measures in terms of percentage using various classifiers. So here SBM classifier, MLP classifier, LSSM classifier, and this random forest classifier. And this is like this is order 0, order 1, 2D FBSEWT, and this is the cross validation. So like 2, 4, 6, 8, 10. And if you have 10 cross validation, means you are dividing this entire features into 10 parts, and 9 parts you are taking for training, and remaining one for testing purpose. And you are doing this for all possible combinations. So here, this actually figure shows the error bar plots for average performance measures in terms of accuracy, sensitivity, specificity for SBM, LP, LSSM, RF classifiers. And first one, upper one is for 0 order FBSEWT, and this is for first order FBSEWT. And then yes, it shows the error bar plots average accuracy obtained from 10-fold cross validation, number of features, and Bhattacharya space algorithm, entropy, receiver operating character, student test, Wilcoxon test. And then this is the accuracy plot of various ranking methods for data R1, R2, R3. And then this is actually this is the proposed method, second one, like this is based on the convolutional network. So here we have this green channel, then we apply 2D FBSEWT methods, we have 4 subband images, and then residual network, 50 is classified, and ensemble we have used, and soft noise layer, it will identify whether it is glucomine healthy. So you don't need to extract any features here. And then this actually this table shows the performance of this 2-dimensional FBSEWT method for full half and quarter frequency scales for R1, R2, R3, this TGS, and this Origa databases, and then different scales. And here this performance measures for order 0 and order 1, 2D FBSEWT method for full half quarter scales. And you can see this different ensemble layers from average pool layer, different cases. And then actually we have compared our method with other existing methods in the literature which have been studied on same databases. And in the proposed method, first, these all methods, they use handicraft features, like designed features. They are extracted features from the images and then apply conventional classifier like ANN, SVM, etc. And the proposed second framework, we have compared our method with the methods which have used CNN kind of. So in both cases, actually our proposed framework has provided better performance. And then we have also seen the how computation time of various stages of this proposed approach. So like it is in milliseconds only, like very seconds. So like in seconds. So this shows that this proposed method can be implemented for real-time application. And we have some of the features of 2D FBSEWT method. By using FBSE spectrum instead of Fourier transform, we get better boundary segmentation. And the proposed method 1, best results are obtained using order 1, 2D FBSEWT method with PCA and RF classifier. And then proposed method 2, order 1, 2D FBSEWT method subimages at full frequency scale with fusion ensemble model has provided better results. And results and computation time of both methods indicate that methods are practically implemented. So after that, this is for empirical wavelet transform based on 2D, like this was defined in Fourier Bessel domain. But here this is based on Fourier domain only. So this work actually done by the earlier before that. So EWT method is used to decompose the image, and core entropy features are obtained from the decomposed EWT components. And then these features are ranked based on the T value or probability value. Then these ranked features are applied actually for the classification. to the classifier, and they classify normal and glaucoma images. So for the study purpose, we have actually taken this private database that is recorded by us. In the database, we have 30 normal and 30 open angle glaucoma images. And these images are obtained from Kasturba Medical College, Manipal. And this is certified by the doctors of ophthalmology department. And public database, we have taken this from the medical image analysis group. And this is, it has 255 normal and 250 glaucoma images. And then we have studied for both methods as well. So this is the proposed framework. So here you can see we have taken normal and glaucoma images. Then we obtained RGB and gray images. And then we apply two-dimensional empirical wavelet transform. Then we obtain the subband images. Then we extract, compute the corentropy-based features. And corentropy is studied in speech, one-dimensional signal, but nobody tried in the images. So this first time actually we used for this fundus images. And then we perform feature ranking. Then least square support vector matching classifier. Then it will identify the normal and glaucoma classes. So here you can see normal and glaucoma image. And this is the green channel. And this is average row spectrum. And this is the filter design using from spectrum based on the Fourier Fourier spectrum. So this here you can see this is the obtained red, green, blue channels, and green, red, green, blue channels, and this RGB grayscale image. And these are the each case, these are the 4 subband images obtained from empirical wavelet transfer. Then this first one is for glaucoma subject, and this one for normal subject. And then we have extracted this feature corentropy. And this corentropy, it requires actually based on the dimension, this parameter epsilon 3, or g equals to 3, you can actually change the number of corentropy features. So this corentropy is a function of capital G. So here G is equal to 3. So you have 3 corentropies. You can have 5 also, 6 also, accordingly. Features will be changed. You can study this actually feature for other classes also, other classes of biomedical signals. And since there are 4 components, yes. Yeah, yes. But each G, it will compute the relation between its image versus its own form. So it's like a correlation kind of thing. But instead of correlation, it is the entropy. So it goes for probabilistic measure. So statistical way, it measures the similarity between its own form, its shifted form by that G parameter. So different orientation, you are getting the similarity, but that is statistical way, it is similar. It's very useful parameter, and you can tell like in speech it works very nicely. But in biomedical, like phonocardiogram signals we have studied, but EEG signals that nobody has tried. You can try these EEG signals. This corentropy is very strong feature. And out of these 12 features, first 6 features selected according to t value. So this you can see these features, 6 features we have computed a normal glaucoma t value based on the t value. And this is for for different R channel, G channel, B channel, and gray images for this private database. And we have used radial basis function, modeled wavelet, and Mexican head wavelet kernels for the classification with least square support vector machine classifier with the 3-fold and 10-fold cross validation. And then we have compared our method. Actually, we have got this 96.6%, 67% classifier accuracy. And we have compared this method with other existing methods in the literature. So they've used a lot of signal processing and machine learning and this accuracy. So this is the last one is our proposed method 98.33, and you can see other methods are not up to that number. So that's performance. So after that, actually, this VMD, variational mode decomposition method we have proposed. Variational mode decomposition is the improved version of the empirical mode decomposition. Empirical mode decomposition, there is a lack of mathematical theory, and also there is mode mixing problem, and doesn't work in the presence of noise. So actually, they formed in this VMD paper they formulated the signal decomposition approach as a optimization problem. So they optimize components. So luckily they got Wiener filter kind of a structure. So Wiener filter is actually very lowest to noise, and that is very optimum filter for the image processing. So Wiener actually during his MS time, he developed this Wiener filter. Wiener, his time when he was MS student, so he come up with this filter, and this filter was giving very good results. So he tried to publish in many places, but no electrical journal accepted. No, this is not like properly explained like this. So what Wiener did, Wiener actually wrote this filter in the form of report and kept in the lab, and left to his native place, that university. And this filter was so good. After people are started applying this Wiener filter, and they got very good results. And many people were using Wiener filter without publication, and with their citing report and using. Then after that, Wiener published that work in mechanical journals. And today, Wiener filter is the optimum filter in image processing. It is the best filter. So, it was not published in electrical engineering. No, people did not understand it. So, doesn't mean that work is not good. Sometimes, actually, research, good work takes time. There is saying, if food is taking time, then it is good for health. Similarly, if your work is taking time, this means some good results are going to come. So, it's like good work always takes time. People like a Wiener filter, Fourier transform, they take years to understand by people. And sometimes there is resistance also from the people. If you do good work, then there is a resistance. If you don't do any work, then no resistance. Everybody is happy with you. You are a very nice person, gentleman. And if you are doing, then problem. So if you are not doing, then there is no problem everywhere. If you do, then there is a problem. Least square support vector machine is the improved version of support vector machine. So there is a in SBM, this constraints, they are actually they are not equality. They are not set of linear equations. They are constraints. They are inequality, like greater than. So that requires actually computational complexity. So in order to have less computational complexity, we convert this support vector machine, this mathematical formulation, into least like a set of linear equations. No, least this is LSSBM. So that is LSBM. So this is an improved version of SBM, where you can formulate this classification problem in the terms of linear equations. So it is a binary classifier. There is actually a mathematical function where it requires your features, and based on features, kernels, and it will give you either 1 or -1. If it is 1, then you have this one class, -1, then other class. So it is a binary classifier. So based on the boundary, we have kernels, so you have boundaries in different regions, and that actually can be detected by the LSSB class. So it will give you the regions to separate regions. So in linear plane, actually in the feature space, you are not able to classify. So we are going in such a feature space where you project your data higher dimensional space, there it will be separated. So here we have actually we have applied the VMD method, and then this nonlinear entropy based features are extracted from the VMD components. And here this method also provides 95.19% classification using LSSM classifier. Yeah, so that is actually non-linear or linear. This is based on the superposition principle. So any entropy, if it is always, it follows the superposition concept, that is homogeneity and additivity, then it is a linear feature. Otherwise, it is a non-linear. So the superposition principle, if it is satisfying that computation of the entropy, then it is a actually linear, otherwise it is a non-linear. So this is a simple VMD method, normal glaucoma images, then green channel obtained. Then we applied iterative VMD. What we have done, we have applied like instead of decomposition of all these components. Actually, to VMD, it requires selection of the parameters. Number of components you have to give in the prior. So now you don't know how many components are there in the image. So what we have suggested, you take two parameters, number of components 2. So this is like wavelet decomposition. So here, this green channel will be decomposed into two images, low frequency and high frequency. Then you take high frequency, then again decompose into two components. So in that way, go up to 5th iteration, then you will have total 10 subband images. So that we call iterative VMD. And then we obtain these features from these components. Then we apply LSS UMD square support vector machine classifier, and it will classify this into normal and glaucoma classes. So VMD is actually a non-stationary adaptive variational signal analysis technique, and already this like it requires 3 steps: transform the signal into analytic counterpart of the subband, and then we use this estimated center frequency to shift the frequency spectrum of each subband. So in that way, we obtain all these pass bands, kind of basis pass bands, narrow band signal, but they have different mean frequency. They separate it out using optimization concept. Then squared L2 norm of the gradient is applied to estimate the bandwidth. So each actually component we estimate the mean frequency and bandwidth. And from that estimation, we try to reconstruct that component. So here you can see this is like this is the optimization problem, but we are solving in this optimization problem so that when you combine all modes, then you get the signal back. And this is the constraint problem that is actually using Langmuir multiplier. And then this is the estimation of the average, like this mean component in the frequency domain, and this is the mean frequency. So this is one example. Here, this is the iterative VMD components for a normal fundus image. So here you can see the 10 subband images, and similarly for a glaucoma case, there are 10 fundus images, 10 subbands of fundus image. Then we have extracted these features. This is like entropy and fractal dimensions. So this is Kapoor entropy, and this one is Renai entropy, and this one is Jaeger entropy. So 3 features they are computed. They are non-linear in nature, that you can see. And then this fractal dimension is defined mathematical way by using these expressions. And then we have actually this feature selection is done, ranking, and then we have done classification. So this is the relief method is used for the feature ranking. So here you can see different features, and the normal and glaucoma case is mean standard deviation, and that is actually showing the different regions of the feature space. And then this here is the plot of accuracy versus number of features for this 3-fold and 10-fold cross validation. And this performance measures are accuracy, sensitivity, specificity. And here we can see this effect of kernel parameters in both cases 3-fold, 10-fold cross validation for this classification performance. And then we have compared our method with other existing methods in the literature, and that you can see it is also giving better performance than the other methods which have been studied on this same database. After that, recently, this VMD based, quasi-bivariate VMD based approach has been proposed in the literature, which gives relatively more smoother components, and that actually nobody has studied this image processing. The first time in this work, quasi-VMD, that you can try for various medical images. Quasi-bivariate VMD based method. So this gives you more smooth actually components compared to the VMD. So this is the proposed method. We done pre-processing of the input images, decomposition using this quasi-variate VMD, then feature extraction, normalization selection, then we do dimensionality, then we apply SPM classifier, and it will give you the automated classification between LD and glucose. So here actually this is quasi-vivid and this is the algorithm. So here we have selected number of components 5. So this is for healthy images, healthy fundus image. You can get 5 subbands, and this is for glaucoma fundus image, 5 subbands. And then this feature extraction here also 17 different feature sets have been used. So like germanic movement, whose invariant movement, chip histogram, texture fetch features, ELCM. So these are all texture-based features. They have actually tried in this glaucoma fundus image classification. And out of the 70 features, we have selected 45 features. And then we have used this classifier, LSSM classifier, and that actually provides you this is the obtained accuracy, sensitivity, specificity, using 3-fold cross validation and 10-fold cross validation. And then actually here you can see the performance of this in terms of fold numbers, like and kernel parameters for the different accuracy, sensitivity, specificity, and different R values for this the different like for the this classification performance. So this is the conclusion of this talk. The image analysis techniques together with machine learning algorithms are useful for designing automated system for classification of fundus images, and the obtained classification accuracies are very high. And these methods can be implemented in the form of software in the smartphones and computers. And computer-aided medical diagnosis can be performed based on these devices. And that developed methods should be studied on wide database before using them for clinical purpose. And these are the references. And after that, actually, we also do different kind of work also in our laboratory. So this is one of the work is a computer-aided diagnosis of coronary artery disease based on the non-state signal processing. So after 70s age, actually, people develop this coronary artery disease. So arteries, they actually the blockages take place. So there is no blood flow. So due to that, actually, there is narrowing of arteries, which gives the blood supply to the heart muscles. So that actually this coronary artery disease can weaken the heart muscles and may cause the arrhythmias and heart failure. So we have proposed this year. You can see this is the there are 2 types of study generally people do. One is ECG signal based diagnosis of coronary artery disease, and second one is heart rate variability, heart rate, HRV, heart rate variability, HRV signal. So if you have good hospital, like a good clinical setup, then you go for ECG. And if you are recording the ECG signal in the farm field, there is a lot of noise, then you go for heart rate variability, HRV. So heart rate variability just is based on the RR peak. So RR peak is the highest actually energy part, highest strength of the ECG signal. And from that, if you determine RR interval, then actually that is not noise sensitive. So in that way, heart rate is actually still can be computed even in presence of noise also. So here we have used the RR interval also, and the other work we have used ECG signal also. So this the first time in the literature. Now many people have tried TQWT, but we were the first one used the TQWT in 2015. And where we have actually from the heart rate signal, we applied TQWT, universal wavelet transform based decomposition. Then we extracted features, then transformation, then classification. In that way, we can detect coronary artery disease and normal heart rate signals. And that is very useful for the this diagnosis of coronary artery disease. And you can see this is our method we have compared with other existing methods in the literature. And then there is actually like when you have heart sound, and then actually this all the cardiac events that take place during heart beat cycle of the cardiac sound signal. Heart is actually is very in the day 24 hours it beats more than 1 lakh times. Now you can think how much hard work heart is doing. From the beginning, when we are born, till death, it is always actually working. In the day, it is actually, it beats more than 1 lakh times. And breathing, whatever like breathing we take, that is also, it is around 25,000. So this chanting Hare Krishna Mahamantra, there is when you see the Shastras, they say you should do this mala 16 times. So 16 times means like each time you are saying Hare Krishna, Krishna Krishna, Hare Hare, Hare Ram, Ram Ram, Hare Hare. So Hare Krishna. So this is like 16 times God name you are taking. Hare itself is name of God, Krishna itself is a name of God. So each part has 4. So total 16 names in one mantra. And if you are doing this 108 times, so 16 into 108. And if you are doing this mala 16 times, then 16 into 108. So that is around 25,000 something. So this means every breathing you are actually remembering. So we don't know when actually time will come to go from this world. This is nobody knows. We have come, date of birth everybody knows, but we don't know when actually. So this whole time people used to do this japa 16 times. So every breathing, we don't know which breathing is the last breathing, and whenever actually you're going back, then actually you're going with that name. So that is what the reason. But now scientifically we are actually finding a way why 16 rounds of the chanting. That is why this old time people say, "Jo kar lo wo kaam hai, bhaj lo wo Ram hai." So actually 2 things we should do. We should, for whatever work you want to do, you do it, and whatever like japa also, that is also you should. These 2 things are important. When actually Ravan was very intelligent, and Ravan was dying, then Lord Rama asked Lakshman, you should learn something from Ravan also. So Ravan is going to die, you ask something, we should learn from each other. And then Lakshman went to Ravan. Ravan told to Lakshman that actually in life, whatever he has learned from life, that good things always you should try to do as soon as possible, and bad things you should try to delay as much as possible. So if anything is good, if idea, then do it quickly. So whatever is the best time in your life. In future we don't know. And that is always say good time will come, good time will come. No, it is always good time. Whatever time, that is the best time. This is like if you have any idea, you do it. Delay bad things, not good things.
Suppose you are going to do so bad.
Bad things means like a battle. There was bad thing is like a battle between Lord Rama and Ravan. This battle should have been delayed. They good things they did not delay, and actually they focused on this battle. So if something is like you have something like that is not significant, that we can delay. We have to filter out which one is good. Right? Because life you have many things like instead of one frequency, you have a band of frequency. You have to identify which one is good. That is resolution. You cannot have any frequency at any point of time. You have frequency in the band, in the duration, but we identify the best. Entire signal processing like that. So this cardiac events that is very beat cycle. So the segmentation of this cardiac sound signal corresponding to the beat cycle is very important, and that is known as the fundamental heart sounds, and that is done by the tunable Q wavelet. So you have murmurs, that is blood flow. That sound IC signal processing can help you to give you the fundamental sounds, so that you propose noise can be removed and nicely actually. And Professor Dr. Niranjan Garg, we are doing some work with him, and you give him this sound, even 1,000 sound he can count, and tell this is the number. Cardiologist. And the signal processing, whatever we do, he without using any method, he just listen, and he will ignore noise also, and that based on the experience he will give us same number. Then actually this epilepsy, And these features, that signal processing, actually we have come up with such geometrical features based on the feature orientation, feature values, feature representation itself, you can detect epilepsy. So this phase space representation, if it is becoming more spread, then it is epilepsy, otherwise it is normal. We have compared our method with other existing methods in the literature. And this is diabetes. These days it is very common. Diabetes actually, and the diabetes has connection with heart. Diabetic people, they have always a higher rate, around 90. So this we have actually studied the heart rate signals also for the diabetic. So you have heart rate signals, HR or RR intervals, a signal for normal case, and this is for diabetic case. So you can see diabetic case, this interval is going to be very less, so heart rate is very high. Yeah. RR values. And this only one problem is that if you don't have other heart diseases. So these days actually people have multiple heart diseases. So diabetic, actually person has diabetic only, then he has high correlation with the RR interval. This is for RR interval. Actually, we can find using this pumpkin algorithm, that term pumpkin algorithm, and then RR parameter is found very less for diabetic people. So yeah, this is the 0.64, around 90. This 60 upon TRR. So 60 upon 0.64. How much it will come? 60 upon 0.64. Hmm? 90. So 90 is always is around 90. Diabetic people. Diabetic people should not take any stress. Life is cool. They should enjoy. Because already like started. No stress, no anxiety, no whatever is coming, grace of God. So this is a RR interval signal normal subject. This is for diabetic. And then actually this fundus image, I think actually we have seen. So this is actually our laboratory, and now earlier actually with time things change. We used to work in signal processing, like now areas also changed. So now our focus is on non-static signal processing, then computer interfacing, physiological signal-based biometrics, wearable devices for healthcare, computer-aided medical diagnosis, and signal processing for mental health. So this is actually very important part. There are two health. One is actually your health of your body. You are having fever, heart rate, you go to doctor, but nobody says that I have problem in my brain. So old time actually people used to take care of the mental health also. So we are studying this mantras, japas, same thing, Rudra mantra happen over actually is with the art of living centers. We are doing that Rudra mantra, and even by listening itself, there is nice delta rhythm energies increasing. So like sleepy pattern, people they don't sleep. The mantras they can help them to sleep better. And Hare Krishna Mahamantra, we have seen you can increase the concentration, focus, that alpha rhythm energy is increasing. So such kind of study actually we are doing. And this is now we are recording our own database and real-time implements of the human activity recognition system that is based on Raspberry Pi. This like this student, like you are making text signatures, it will be detected by the brain tips EG signals. So now we are proposing this biometrics based on your signature at the same time EG signals. So sometimes somebody is making fake signature, quickly signal will change. And this is actually our research laboratory, and this is the maybe the first laboratory in the world where we can record this treadmill data. real-time ECG signal in the computer, and that is actually we have this kind of machine IIT Kharagpur and our lab. And this IIT Kharagpur people, they have just for clinical purpose, this medical college, but we are using for research purpose. This is EEG recording system, this is ECG recording system, this is 3D printer, and this is a treadmill, and this is phonocardiogram signal, digital oscilloscope. And I think this is just actually for different activities. What is the heart rate? Suppose when you are walking, heart rate, when you are running fast like that. So what happens? This we are developing wearable device, and that is for that. That is so intelligent. Sometimes you fell down. Then it will tell you this is not due to abnormality. This is not due to heart attack. You are fell down due to some other activity. So like somebody can fell down, and this device, wearable device, will send the signal that you got a heart attack. But based on the ECG signal or other parameters, it will tell you this person is fell down due to some like physical activity. Now it is coming now. It is this few months you will find many cases. Now it is showing. Post-COVID effect is now started. And now last 2-3 months, I have my 3-4 persons even like nearby my place, they also died. This is post, now this effect is coming. What happened actually, people are not, they have not become active after COVID. People are not working efficiently, not taking exercise. ECG is actually, ECG is just a signature. It's very raw signal, but it can give you the indication whether any abnormality there or not. Whenever we go for heart attack, we go for advanced tests. So this we are developing vital sign monitor. That is actually is a part of the ICMR project. It's 1.25 crore, and last 2 years we are working very hard for that. And maybe next 2-3 months you will see very good news from us. So we are making such vital sign monitor, which will not only take ECG, it will take many parameters from the body. And after that, multi-parameter. All parameters are there, and these, they are IoT is there, signal processing there. They are not just like this hospital monitors. We have prepared, we asked the people to prepare this monitor, which will give you the signal. So this is the first time monitor where signal processing is done. Like this heart rate, we are computing from the ECG signal, and ECG signal is from the multi channels. It is not just like one channel. So whatever this monitor, they are just rough. But that will be the first general monitor. So it is part of that only. This is the project with the IIT Palakkad, Professor Samerandra Manikanandan. Yeah, yeah. That is actually, if you have more this more number of leads, this, then it is like more information. And this actually, have you heard this news from Professor Behra, Mr. Lakshmidhar Behra, director of IIT Mandi? Professor Behra says actually this body, he has been engaged with this bhakti, all these things from many years, like last years. And he says whatever signals you take, it is correlated, like there is no signal is like that is uncorrelated with other one. Like this body, is highly correlated. So even ECG signal, you will not find any person whose brain is very good and heart is dead. Like you'll find these all are correlated. So if you have more number of channels, more number of information, that will give you more reliable actually decision detection. Even more. That is why you want to have more and more. But that is also if you take more number, then computational complexity. So there is a compromise between accuracy and more accurate representation, more accurate information, and so like emotions, we are using EEG signals, and Professor Bera says ECG is also good. And now we are detecting emotions from EEG, ECG, and phonocardiography PCG together. And that is actually first time we are developing this multimodal EEG, ECG, PCG together. Yeah, that is what. So that three actually, like three EEG, ECG, PCG. So that is what now signal processing will help you. So you extract features from each model. ECG, you select features. From ECG, ECG, you select features. And PPG also, like PCG also you extract features. Then feature level you have, then you can process. Good. Corentropy. So try corentropy you can extract from the EEG signals. And then for ECG, you can extract some other features. And PCG, you can extract some other features. Then you take all features together and then you use classify. And nobody knows which feature is good. That is, we have to study. The corentropy can give you good results or not give. This study has to. No, EEG signal, nobody has studied corentropy. You can try it and heart rate. PPG, yeah, PPG. Yeah. Atrial fibrillation, actually, we are ICU people do that. Heart rate, this. Easy. Easy. We are using PPG also. Yeah, also. This PPG is also there, ECG is also there. All are using. Yeah. Okay. So PPG signal, we use signal processing, spectrum.
Complex. But so there is some specific shape, but that's very volatile.
They based on the spectrum, you can detect the first heart rate. Very not complicated. ECG is complicated. PPG is actually we are using PPG for this. For wearable device, it is highly suitable.
Or yours, or
This is a PPG, and this is the wearable. We have design. that actually it has PPG also. So this is wireless. You don't need to do anything automatically. Just you have to wear like jacket. But this is still like under patent all this thing. Wireless. This we have actually took help from that person here. Now jacket will be there. So this is all parts. From last 2 years, all is going on. This is your PPD requirement.
It's a pro.
So
Johnson.
just you have to put, but in jacket all will be there with you. You don't need to do anything. Automatically, this IoT signal processing is there. Delogging will be done, classification will be done. IoT it will go to your relatives also. So family members will also know what are your vital parameters any type of them. When you are sleeping with jacket, people will know what is happening with your body.
Smart jacket.
Smart jacket. And the first time jacket will use signal processing. Yeah, this is. Actually, army people they want make jacket for them. So we told them, yeah, not for us. Everybody is army. Everybody is useful in this world. So everybody is in some way useful. And this is actually our lab is very active, and signal processing, machine learning extensively applied for biomedical ethics. So we have published 10 books, 26 book chapters, and 185 journal papers, and 78 conference papers, and around 15,000 these papers have been cited. And this is the book that actually it took me more than 10 years. So whenever you find time, you please go through this book. The first book from India on time frequency analysis. This is our research group. We are very actually active students. So, these PhD students also consider me PhD student. So like I say we have like 12 PhD students, but my students say that we have 13 PhD students. So they, me also, I am also like PhD student. I learned with them. Any questions?
From online. Okay. For all the online participant, any question is there? For online participant, please unmute. Who is having the question? You do. Aditya. Aditya.
Yes, yes. Am I audible?
Yes,
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 yes.
So I have questions. One is like you said on feature extraction and feature selection. Can I know like how to select a proper feature, sir, for signal processing or even for image processing?
Yeah, actually, so there are like this is very good question. Suppose just for an example, your birthday celebration is there, and you invited me, and I don't know how to take good photo for your birthday celebration. So there are actually two ways. I will take 200 photos, and I will give you 200 photos, and you find best one out of these 200. Second way is actually I will ask your student, your friend, he is very good in taking photos, and he will select proper scale and will take good photos. So in both ways, actually, I am trying to find the best photo out of many. So similarly, the features actually you obtain, is all features are not significant. So there are many methods like critical variance statistical test you can apply, and based on the probability value, if it is less than 0.05, then you can name them significant features. If probability value is greater than 0.05, then you can name them insignificant features. In that way, you can categorize. So this is one of the approach, critical variance statistical test, but you can try other also. Is
Okay,
clear?
so another thing is like if we don't, yes, sir, yes.
Yes. Yeah. Next, another question.
Aditya, any more question?
The question is like if was not audible. Am I audible, sir?
Yes. Yes,
Hello.
please.
Yeah. Okay. The question is like if I give all the 116 features without any selection, and if I give all the 16, will that affect the accuracy?
Yeah, that may be.
Rather
Some
than
features
selecting a feature
actually may
and
be insignificant, so it affects. You should
in
always
some
use
scenario.
the actually optimum number of features. That is like parsimony principle.
Okay, sir.
We should not, if you are using more than the required, then unnecessary is burden, and even you are not affecting performance, but it still affect the completion complexity of the method. So it is always desirable to work with the as less number of features.
Oh, okay, sir. And beyond this topic, I have one question, sir. Like in the performance evaluation, how to correlate the results between sensitivity and specificity apart from accuracy? We have the accuracy. Still, if in classification scenarios, how can we understand the sensitivity number being given, metric is being given, as well as specificity metric is given? So how can we correlate? Do you have any ideas regarding that?
Yeah, but
Because I've been like going
accuracy,
through.
specificity, they are defined based on the true positive, true negative, false positive, false negative.
Yes, sir. Yes, sir.
Based on that, then
They actually
you
different
can
from
interpret
that.
it. There is another standard actually measure, that is the area under receiver operating characteristics. That is
Okay, AUROC.
yeah, sensitivity versus 1 minus specificity. That also can be used.
Okay. Okay, sir. Okay,
Okay,
sir. Sure.
thank you.
Thank you.
All the best.
Thank you.
Anybody is having any? हाँ चलो.
मैं triple I.
Sorry sir for assistant.
No. Assistant professor is also faculty.
Sir, triple IT NR machine learning. This one.
Triple IT होगा.
Triple IT NR application.
Yes, application. PPT कर दो ना उसमें.
PDF कर दूं क्या? PDF
PPT करो. प्रॉब्लम होगा तो PDF यूज कर दूंगा. खड़े होके बोलना पड़ेगा कि मूव कर सकते हैं.
मूव कर सकते हैं सर, बिकॉज
माइक का प्रॉब्लम.
माइक का प्रॉब्लम है. कॉलर माइक
नहीं, कोई इशू नहीं.
उनके लिए दिक्कत होगी तो ऑनलाइन सर ये लीजिए. तो आप थोड़ा मूवमेंट यहाँ तक कर लेंगे तो कैच करेगा ये.
हाइलाइटर. डबल क्लिक हो गया.
ये वाला क्या था सर? लेजर वाला.
right? ये highlighter है. Yeah. अच्छा कोई इशू नहीं, लेकिन आगे भी कुछ टॉपिक sir, you can for the up and down, but for the highlighting it is थोड़ी difficulty. Yeah, this is backward, this is the forward.
So first of all, thank you very much for your generous introduction and warm welcome. So thank you, sir. And in this lecture, I will cover one application of machine learning, and that is for Alzheimer detection using MRI images. I am audible? Okay, thank you. So first, this is the rough outline of presentation, where first we will discuss what is machine learning, what are the different types of machine learning, and different brief, because otherwise one model required at least 1 or 2 hours if we discuss in detail. So I expect that most of you may be familiar with the different machine learning models, but just refresh because to connect with the, and then we'll take medical imaging system. What are the different medical imaging modalities? And out of these different modalities, MRI is one important modality which is used for research as well as for various diagnoses. And this is the use case of MRI for Alzheimer detection. So how MRI images can be pre-processed, how we'll segment these images by using different libraries, because we are not from medical field, so don't expect too much from disease point of view. Okay, we are just our prime focus is to extract the feature. Either if some doctors are associated, in that case we'll take their help, but if doctor is not there, then in that case we'll use some predefined machine learning predefined libraries for different feature extraction, and these extracted features will be used with various models, and then model evaluation. Okay, so first quick recap machine learning. So first of all, what is learning? So learning is defined. Learning is a process by which system improve performance from experience. Whether learning, this same concept is applicable to us as well as for any system. And one misconception that if we'll remember something or if we'll memorize something, it doesn't mean this is learning. Memorization is not equal to learning. Learning is, how will define learning? If we are saying learning is not memorization, then learning is what? Yes, if we remember some fact or storage, fact storage or memorization is necessary, but if we are able to infer something non-obvious thing from the stored data or our past experience, then this is known as learning. Okay, so learning involves ability to generalize from past examples. We know this, and we can generalize this concept, then this is known as. So machine learning, like so building machines. Machines means softwares as well as something hardware that automatically learn from experience. And experience is gathered or collected from past data. Why data? Because nowadays machine learning is a very old field. First, this machine learning term was coined in 1959 by Arthur Samuel. Okay, but in last 10-15 years, machine learning is very much popularized. AI is very old. Okay, from 1955, AI is there. But nowadays, because the fuel for this technique is basically data, and earlier there was no data collection. So after the invention of these handheld devices, popularization of these mobile devices, data capturing devices, sensors, and then again this field regain, and now we can say what is the state of art. Okay, totally it's revolutionized. The whole landscape is totally changed. Now people are thinking, stop. You may be aware about, not part of this lecture, but you may be aware that the debate is on. We should take moratorium for 1 year or 6 months on AI research. AI research. Okay, so just within 1 year, this LLM large language model like ChatGPT and many such applications are there, autonomous car and many things are there. So now debate is going in another direction. Earlier, we are seeking for the development in AI, and now people are looking even you maybe heard that some famous persons which are backbone in DeepMind, they have left these companies and now they are not working on AI. You may have also heard about the LLM. So why these techniques are popular? Because of availability of data. Nowadays, data is cheap and abundant, available in form of data warehouses, data marts. These are the data warehouses, data mart, data lake, database. Okay, these are the terms used for storage of data, whether structured or unstructured. They have their own terminology, their meaning, but it's we can say the data level. Like we are visiting shopping malls, so we are participating in data generation. Our footfalls are counted, our face are recognized there. So they may, if we are searching something, so we are generating data. This data will be, and this past data will be. So data is cheap, but knowledge is still scarce, and it is challenging to extract the knowledge from vast amount of data. So this machine learning is basically learning general models from the data of particular example. Like we'll take one example and we learn from that example and then try to generalize this. Okay, like I learned something from you, and on the basis of my experience, my learning, I will try to generalize behavior of students who attended the Karmshala program of SAB. Okay, like this. So we can generalize up to some extent, not exactly, and build models is good and useful for approximation. So this is the machine learning. These are some classical definitions from like machine learning is a science and art of programming computers so they can learn from data. Author Samuel and this Tom Michel, you may be aware about the famous book of machine learning of this Tom Michel. So different definitions are available. These are the some popular classical definition of machine learning. And like this Tom Michel defined this machine learning in terms of this PT and E. Okay, and so when we use machine learning, so if human expertise does not exist, then we can use this machine learning. If humans are unable to explain their expertise, like speech recognition, yeah, we are our brain is perfect in many cognitive tasks. We are more superior than computers. Like face recognition, where some cognitive ability is required. Speech recognition, by simple the fraction or small amount of sound, we are able to detect the person quickly. किसकी आवाज कितनी भी भीड़ में अगर we are acquainted someone, they तुरंत पहचान जाएंगे हाँ इनको कहीं देखा है मैंने, like this. So there are many cognitive tasks where we are superior, but we are not able. You cannot explain the reason how I am able to identify your voice. How I am, why means I am able to identify your face. So if explanation is not there, then you can solution change in time. Like many solutions will change. Like for particular time this will work, it will change. So for adaptation, quick adaptation, solution need to be adopted cases and getting insights about the complex problem and large amount of data. So in short, we can say the one needs to generalize from experience of non-obvious. Where we should not apply the machine learning, some people apply machine learning everywhere. So there are tasks where definitely we specify all the cases like this payroll calculation, sorting list of word, web server, word processing. There are many more examples where we cannot, where learning is not required. We have to exhaustively perform all the steps. these are some popular example, and everybody very familiar with like this. Every day we are using email services. So now automatically our mails are categorized in spam and the authentic messages delivered to our inbox. So spam filters, and even in writing, if you write something, if we receive some mail, we are replying, so automatically it will give the name. And there are many advancements out there. Recommendation engines used by this Netflix, and this Netflix is hosting movies and shows, OTT platform like Spotify, where songs we can get good recommendation of songs like this. So these are some popular example of machine learning, applications of machine learning. Machine learning is again a very vast field, and the different types of techniques are used there. But in general, we can say these are the broad applications of machine learning. Okay, this you maybe heard about this IBM Watson. This IBM Watson is basically used for. There was a case. This cancer is, there are different forms of this cancer, and some forms are very rare. जैसे अपने एक फिल्म स्टार था, क्या नाम था उसका, कुछ खान करके, या एक कोई फेमस फिल्म स्टार था, उसको एक इरफान खान. सो एक रेयर ऑफ द रेयरेस्ट टाइप की कोई डिजीज थी. ओके, सो इट वाज देयर वाज नो प्रेसिडेंस सच टाइप ऑफ डिजीज इन इंडिया. सो देयर आर डिफरेंट फॉर्म्स ऑफ कैंसर, एंड one such form was detected by IBM Watson. One, the team of doctors, the top doctors of the UK was not. So this machine learning is equipped up to that. And what is the reason for growth of this machine learning? As we have seen the application in almost every field, whether it is entertainment, fintech, finance, or education, or in or like medical diagnosis, or you will find it application of this AI ML applications everywhere. So reason is like every day you will get some new model. So, and with improved, like this transformer models. So attention, LSTM, there is nowadays the whole pipeline is available for very, very complicated tasks. So every day something new is available, and that to be most of things are available in open, as open. So improved machine learning, availability of open source ML libraries. How many ML libraries are available? If the same thing we have to do by hand, then many of the researchers or many of the students will demoralize. So why people are adopting it is because quick adoption. We can learn these libraries within a period of week or within a month without too much technical background. Everybody can do. Okay, and then improvement in the data capturing. Earlier, the camera was very sophisticated, but nowadays every mobile device has data capturing capability. Sensors are there. Every form of senses is what as a human we sense. We can capture this. We can capture the smell. We can capture everything. We can capture. Okay, and this demand for the self-customization to the environment. So these are the reasons. These regions are propelling the growth of this machine learning. And just to give a picture, you can see this is the whole landscape of machine learning, where different types of techniques are there. And here you can see how many algorithms are there. And these are the tools, ML tools. Most of the tools are available free, like MATLAB. So MATLAB is proprietary item, very costly. So alternative of MATLAB is, which one is free alternative of MATLAB? No. In that category, MATLAB like software. Octave. Okay. So if you don't have MATLAB, you can switch to Python is available, Python libraries, and this scikit-learn, pandas, Seaborn for plotting, for everything you can think, things are available. Okay, for deep learning, the CNTK for natural language processing, and that these libraries are available by different. So what I mean this is also the one of the reason available facility. If suppose you want to work in NLP, otherwise it requires lot of effort if there is no facilities available. So, but in that case, so this is also the important reason what I feel for the growth or development of. Now, just to summarize, machine learning, you may be heard or you may have read the different models and different contexts. So broadly, these machine learning models are classified into 2-3 categories. Again, this is not exhaustively. They can be rearranged in different way also. But the major category is on the availability of data. How data is available, and how we are getting this data, and different types of models. So on the basis of availability of the data, like we have samples, training samples, as well as labels. So data, like I have training samples, I have also these training samples are labeled. Like for example, I have 100 X-ray images, and label means doctor annotate this X-ray is this X-ray is used for this disease, this X-ray is used for this. Like, so this if labels are available, so how this data is available? This data can be available with labels, without labels, partially labeled, or like this. So on the basis of availability of data, these models are classified into supervised, unsupervised, and real. So basically 3 techniques: supervised, unsupervised, and reinforcement learning. Nowadays, reinforcement learning is supervised is almost saturated. Supervised, unsupervised is almost saturated. One more, we can combine the supervised, semi-supervised, where because the cost of labeling is very high. Okay, because labeling is done by, like if you are taking MRI images or X-ray images, so who label them? Doctors. So cost of labeling is very high. Otherwise, the applying supervised learning is easy, but just because of label data, in absence of label data, the other techniques. So these are the main techniques. Then semi-supervised, active learning, transfer learning. These are the different variants. How we are getting this data? Online or offline mode. Okay. And what are the different types of model? Like this is the example of supervised. You may be aware in supervised learning. Here you can see these are the different data. Like it's used for training. It may be of text. It may be of documents, images, sound, any sort of data. So first we have to convert this data into feature vector. Okay. First, we have to convert this data into feature vector. We'll come to how to convert this data into feature vector, and then we'll also provide the labels. So this feature vector and label will use to train the model. Then such type of models are known as machine learning model. Like this for email, if we have 1 million, you may be aware about the Enron data set of email. If we have 1 million emails and it is labeled that this email is a spam, this mail is a ham like this, and we'll train our model, then automatically it will learn. And for testing, the same, we'll convert the feature vector, and then so such type of models are known as supervised. If our label is discrete in nature, discrete means we have some categories like 1, 2, 3, 4, 5 classes, then such type of problem is known as classification. If our labels are continuous or real values, then such type of problems are known as regression problem. So example of regression problem, what are the examples of regression problem? Although both are supervised, simply like house price prediction, stock price prediction, where every output may be of anything. And classification is, if we have like this email classification, 2 class, 3 class, like disease diagnosis, whether person is suffering from disease or not. So classes may be of 1, 2, 3, 4, 5. It can be of any number, any binary class or multiple class, but it will not be a real number. Okay. So on the basis of what is the difference between prediction and regression, or what is difference between classification and regression? This only, the label. In both, labels are required. But what is the nature of this label? If suppose 100 classes are there, so it doesn't mean this is a regression problem. Still, these are the discrete values. But if continuous values are there, then it is known as regression problem. So almost all models are available for classification as well as regression. What is the difference between model and algorithm? Yes. There are algorithms like supervised support vector machine, naive-Bayes algorithm, decision tree, random forest. There are many algorithms. So what is the difference between algorithm and model? Interchangeably we use these terms. So here, this is algorithm. When algorithm will train, if algorithm will train, it will convert into model. So trained algorithms are known as, if we'll provide training data to the algorithm, then it will be converted into model. Now here predictive model. This model is used for prediction. Then another thing is, what is the difference between, there are different terms are used. Okay, for this, one is attribute, another is feature. What is the difference between attribute and feature? Anyone? Is there any difference or both are same thing? In machine learning, feature vector, like we are using this feature vector. So what do you mean by this feature vector? Please be quick. What do we mean by, anybody? Abhishek? Yes, we cannot give whatever. Just suppose I want to train with some text. I want to train my model with text, with image. So these raw text images cannot be fed to the model. I have to convert. I have to extract some features from this data. Okay, and attribute. What is the relationship between attribute? One attribute may lead to multiple features, like salary. Salary is attribute. How multiple features can be generated from salary? Like what is the minimum salary? What is the average? What is median? So these are the different salary values can be generated. So this is the difference between feature vector is the numerical representation. Like suppose I have an email. So how email documents can be converted into feature vector? I will extract some value from email. Like what are the points? What are the things which will contribute in whether this email is a spam or ham? Like there are many words. Spam mail में क्या use होता है? There are different words are used like lottery, friendship, offer. Okay, offer may not be, because offer genuine mail may also give. So such type of words, some exclamation mark, some means that by looking at content, we are experienced person. Okay, so by looking at the content, we understand whether this mail is a, like you may receive text in mail from income tax department, your refund is due. Okay, just click this link and you will get. So such type of, we easily understand. So we can extract the feature either from the subject of the email or content of the email, and then this document will be converted into feature vector. So feature vector, you can say, you may be aware about the vector, matrix, tensor. Okay, what is the relation between vector, matrix and tensor? Vector is basically one dimension. Matrix is two dimensional. If more than two dimensions are there, tensor. तो अभी tensors पे work हो रहा है. Okay, so these are the some basic things. The same thing here, the absence of label only. Label is not there in unsupervised. If label is not there, then how it will learn? If label is not there, then how it will learn? It will search for, like if there is no, this is the class and we have to form the group. Without knowing anything about this simple data space, I have to form a group, categories, 3, 4, 5. So one category is very easy, male, female. Okay, simple, without knowing anything. Yes, female, male. Another category is, we can like MTech student and PhD student by looking at their age, personality. If I need some more, then I will ask something to speak. Then by their accent, The accent can be a feature. I will not ask anything like you are from Bengal, you are from Bihar, or you are from Chhattisgarh. I will ask simply, they will speak something and silently I will observe their accent, and on the basis of this, this accent will be used as a feature. Their language can be used as a feature. So in this way will form, automatically will form the, on the basis of their other properties, will determine their similarity. There are similarity functions like cosine similarity, Descartes similarity. So such type of measures will be taken. And on the basis of these measures will form the group. Okay. So here the same documents, your previous example, this is the same repetition of the previous example. Here same type of data, same feature vector. One thing is missing, which is label. But still, without label, it can be trained by finding this hidden patterns through different similarity or distance measure and form. There are different, but it's not so simple. But yes, the way will be this. There is mathematics, like we have to estimate the, you may be heard about the maximum likelihood estimation, and Gaussian mixture model. Different clustering algorithms are there, association group findings are there. So such type of probability distribution, what type of distribution this data is following, like this. So in this way, we can, this is the example of unsupervised. So what are the example of unsupervised learning? Like clustering, association rule mining, this our dimension reduction technique, PCA, principal component analysis, very powerful technique. What it will do? It will compress. Just suppose one thing is represented like image compression and technique hoti hai. We can reduce the size of an image. So how we can reduce the size of image without distorting the meaning of the image? Yes, we will find the main component from that image, and these main components will represent the image as it is. So these dimension reduction techniques are also used. And this reinforcement learning is different type of learning. Here there are three things are there. It is the state, and the learning system is known as basically agent in its terminology, and state, action, and reward. So if system is, suppose I am in one state, okay, now I will take one action, and on the basis of that action I will get either reward or penalty, and that reward or penalty will decide my next move. Like जो गेम प्लेइंग होती है, like चेस के गेम में हम कुछ मूव करते हैं, अपोनेंट कुछ मूव करेगा. So हम ऐसा नहीं उसमें unilaterally we will not move anything. Our move will depend on others' move. Similarly, for like this game playing, this robot path in a maze, and then this our automated this nowadays this driverless cars. So they will learn from the environment. Now these cars are training in many cities in Europe and USA. Now they have deployed on road as a pilot project. So these are trained action reward, how they will perform the action, whether they are getting. So here you can see this example. So this is known as this system is known as reinforcement learning, and now this reinforcement learning is getting lot of attention just because of its application. Okay, just because of its application. So here you can see the same thing. These different types of techniques, how they are used. Like these are some images, and we will extract some features. See what are the features. We'll train model and apply this apply model to case data. We provide the data and we get the output, whether it's cancer or not non-cancerous, or diabetic or non-diabetic, or anything. It's a general representation of supervised. Similarly, unsupervised, heterogeneous population, and multimodal patient data. Like different types of data are there. Multimodal means, what do you mean by multimodal? Nowadays, multimodal information processing is also gaining popularity. What do you mean by multimodal? What? Yes, multimodal data means data collected from multiple sources like text, image, our this physiological data, And these different types of these data, if collected together, then such type of processing is known as multimodal decision processing. So multimodal patient data, and it will form like we have discussed. It will form when we will apply this multimodal, like our male female. Okay, so this is gender. Then the way of how we wear the cloth. This is India. Yeah, most of the in India easily you will, on the basis of how they are wearing the sari, most probably you will tell from where this person, this woman will belong. Not in all the cases, but in most of the cases. By their way of speaking, you will, like I am speaking in front of many of you may know. You may not know, but you will guess my basic reason from where I belong. Okay, you may be sure that I am not not Bengali or not Odia. I am Hindi speaking and somewhere like this. Okay, so these are some hidden features. So the same thing is applicable. What we ultimately, why we are using all this technique, we want to mimic our decision process through machines. So how we judge the thing, the same thing we want to incorporate into our model, and in this form we form the. So this is just for how we can use, and there are other active learning, transfer learning. It will take time, so I will just avoid it. Then another classification is based on parametric and non-parametric model. So parametric model means learning model that summarize data with the set of parameter of fixed size. Like independent of number of training example is called parametric model. Okay, if in simple word, what is basically machine learning? Machine learning, we use y equal to fx. X is our input data, f is a function, and this we want this f will learn from this x. Okay, if this learning is independent of the training size, this is suppose, and rather than learning from the size of the data or number of training sample, it will learn some parameters like our regression model, linear regression, or our neural network model. So these models learn the parameters. So such type of models are parametric, non-parametric. It doesn't mean that non-parametric do not have parameters. We asked this question multiple times, even PhD, those who have done their PhD, what do you mean by non-parametric models? So their first answer is the models we don't have any parameter. There is no such model where we don't have any, like KNN. KNN is example of non-parametric, but KNN, K is a parameter. Okay, so it doesn't mean, that's why I'm categorically emphasizing non-parametrics. One have a lot of data and no prior knowledge, and when you do not want to worry too much about choosing just right feature, and we directly learn from the data, and the learning will affected by the number of training sample or size of the training data. So such type of models are known as non-parametric. So example of non-parametric like decision tree, k nearest neighbor, and example of linear regression, logistic regression, neural network. These are the example of parametric model. Okay, so this is also the one way of parametric, constant number of parameter independent of the training data, number of samples, number of parameter grow with the number of training data. Strong assumption about the training data, like parametric model will assume some distribution of the underlying data. This data will follow, if not following anything, then we will assume it is following the normal distribution. So if we have any assumption about the distribution of underlying data, like if I am applying parametric model on you, suppose you are a population. So parametric model will definitely assume any distribution, how you are distributed, means what particular pattern you are following, and non-parametric pattern and non-parametric models will not, no assumption about the sample data. and fewer training samples are required because here the quality of training is not affected by size of the, and here many training. So its parametric models are fast. Why fast? Because here their focus is to learn the parameter value. जैसे for example linear regression में क्या learn करते हैं? What we learn? Coefficients learn करते हैं, and on the basis of those coefficients we will finalize the line. Okay, and similarly neural network में क्या learn करते हैं? Weights learn करते हैं. जब weights हमारे constant आना शुरू हो जाता है, हम training stop कर देते हैं. Exactly, we are doing this thing. So we are learning parameters there, and then another category is generative and discriminative model. So generative model, discriminative model means they will draw a decision boundary between the different classes, and this learn the decision boundary between the classes, and these are the two technical like maximum conditional probability and cannot generate. So like SVM, random forest, decision tree, KNN, neural network, these are the example of this discriminative model. And generative model learn the input distribution again. Now the one field is generative AI. Okay, so it will learn the input distribution of the data and generate the new training samples. So like hidden Markov model, neo-Bayes, LDA, Gaussian mixture model, these are the example of generative model. Generative model means they will generate the new samples, or they will learn the maximize the joint probability, and here maximize the conditional probability. And their way of working, they will simply discriminate through a line or hyperplane. If data is linearly classifiable, then it will draw a line. If it is non-linear data, then it will draw some decision tree. So here, this is we can show now. Come to the our point here. How this first we will identify the problem. Okay, what is our problem, and then identify the problem. Then formulate the problem. Formulate means how we will conduct the research, how we will perform the experiment on this. Just suppose some real world problem, like by using MRI, we want to detect the dementia condition, dementia or Alzheimer condition for MRI. This is our problem, is the detection of Alzheimer. Okay, the detection of Alzheimer. So definitely there will be some existing method for Alzheimer detection. So what are the issues with the existing method? What are the existing method? Like we have to interview the patients, ask in many questions, and if they don't feel comfortable, then they may not give you the actual answer, and you may not be able. So how we otherwise we can do it? So we can take some that tests like their CT, PET, or different types of models. So first we have to identify the what is problem, then how to formulate the problem. Formulate the problem. If I am taking this test, is it possible to solve this problem by taking this test? And then here you will see for formulation of problem is domain knowledge. Domain knowledge is this person is the expert of domain. Like we are working, or we are suppose someone is working on ECG, EEG, or some medical data. Okay, but for medical conclusion, we require the interpretation or support of doctor or domain expert. So in formulation of the problem, just suppose hypothetically we formulate anything and which is not very much in line with the medical principle. So this domain knowledge will contribute in formulation of the problem. Then if we have formulated the problem, like this is the problem and this data is required, then we have to collect the raw data. Raw data, like just suppose we have to collect the images, X-ray images, whatever email classification hai, to emails. Then we have to extract the feature, because this raw data is, yes, this is the main source, but not directly usable to models. Then we have to collect feature extraction. Again, the domain expert. Like if someone is very good, like doctors, so you have collected 100 X-ray image, but who will tell you that fact that this spot will represent this thing, this spot will represent if this area is too large, or if the color is not so, then this will indicate this problem. Who will tell? And on the basis of that expertise, we will extract the feature. Just suppose doctor will locate some regions in your X-ray report. Then we have to try. So what should be the standard value? This area should be of that micrometer. Okay, but in your X-ray image size is large. So what now will extract the feature? We will calculate the area of that marked spot. If area of that spot is more than the standard value with some percentage of variation, then we'll say that this image is showing some abnormality or indicating some disease or something like that. So for feature, so in this way, these features are decided by the extract. So you will find that in most of the problem, like what we are doing or our colleagues are doing, they use the standard feature. If you contribute some more feature in your problem, like you extracted 2-3 more features, then this is the novelty to that one. And then with the help of this extraction of features, some predefined feature, some standard feature, and we can form the feature vector and use training data, train the algorithm, and then this will be converted. So especially in case of machine learning, domain knowledge and this feature extraction. This field is known as feature extraction is known as feature engineering. Like nowadays, you may be heard about one term, prompt engineering. In context of large language model or chat GPT, and then the new field is emerged, prompt engineering. So similar in case of machine learning, the feature engineering is equivalent. Feature engineering the key of machine learning. What is the difference between machine learning and deep learning? Anybody? What is the difference between machine learning and deep learning? Any angel? In deep learning, there is no feature engineering. Feature engineering part will be taken care by the model itself. How this model will do? Not aware. Model will extract some mathematical formula and ultimately it will give you a good result. But you cannot explain the reason. That's why nowadays XAI is going to be very popular. What is this XAI? Explainable AI. You may be heard about the lime shape, these models. Okay. So because this whatever we are just to start, that's why we are discussing. Otherwise, practically there is no use of machine learning technique in such type of problem. Deep learning, transfer learning, knowledge distillation technique, the field is far away from here. But still, these techniques are very much relevant. This feature engineering is very well relevant. Until unless we don't know about the feature engineering, we cannot explain it. So there is a difference between deep learning and machine learning is only one thing. Absence of feature engineering is typical part of machine learning. Identify the relevant feature, formulate that feature. Suppose you have identified the area, then now you have to make a formula how to calculate this area. It is not necessary that area may be of circle, it may be of anything. So you have to design a formula, then write a code. So formula, first feature should be correct, formula should be correct, then your code should be correct. Then only you will be able to extract and then some values may be large, some values may be scale. Then you have to perform some normalization, scaling. There are so many, some values are missing, so you have to perform the imputation technique. So feature encoding, suppose some features are categorically, some are numerical. In learning model will take only numerical values. So you have to perform the encoding. So feature engineering is a full-fledged subject within the machine learning. This feature engineering is the most typical part of in machine engineers line. Carefully, you have to curate your feature list. Then we have to perform many feature selection techniques, dimension reduction techniques. Okay, so deep learning models are superior, but their output is black box in nature. So what we'll use now, explainable AI is gaining popularity. Explainable AI model will tell you the reason why this image, why your model is giving better performance. Which feature is contributed up to what extent? If you are getting 99%, then what is the reason? Okay. So this is simple. The same thing what we features are like any problem will be converted this form in machine learning. Whatever be it, you have to convert into this is standard template. You have to find this x1, x2. This x1, x2 will be vary for problem to problem. In case of image, it will be different. Suppose you have to identify the fruits. Fruits को identify करना है. Fruits को कैसे identify करेंगे? क्या features हो सकते हैं उसमें? Attribute. कुछ attributes होंगे जैसे fruits में shape होती है, texture होता है, weight होता है. Okay? So these are the features. जैसे एक fruit दूसरे fruit से कैसे difference होगा? ऐसे face recognition. How we are? Yes, there are. Why still in exams and people are taking our thumb impression? Thumb impression was very old technique. Yes, these thumb impressions are very unique in nature. Signature can be duplicated, but thumb impression cannot be. उसके अंदर features होते हैं. कुछ lens वगैरह लगाते हैं ना? Lens तो actually फिल्मों में दिखाते हैं, but you can extract some unique feature out of this thumb impression. So we have to convert our problem in this way, and then we'll apply. If it will be otherwise, then this column will not be there. Okay. But we have to extract these features. These features may range, like if you are working on genomic problems, so these features may be of 10,000, 100, 200, 500, 10,000, 1 lakh. This feature can be of, you can imagine the size of vector. If your data is of 1 million, then the size of the vector will be 1 million cross 10,000 like this. So it's a huge data. For image point of view, I just listed some feature. Okay, it doesn't mean that these features are applicable everywhere. These are the image related feature. Like if we don't know much, then raw pixels can be taken as a feature, or we can take the GIST feature or global image features. Texture analysis feature, these are very popular. They may be statistical, they may be structured, they may be model based, they may be transform based. So we can extract these features like statistical, like first order histograms. We can find out the histogram of image, like this is the image. Okay, and this is it's a histogram. So these are the first order. Second order, we can take GLCM, GLRLM. Anybody is aware about what is this GLCM, GLRLM? Those who are working in image processing. These are the statistical features. So generally, image is converted into gray level. These are the gray level co-occurrence metric and gray level run length metrics. So these and these in GLCM there are 10 features are there. In GLRL 10 features are there. But generally the code is available already in form of so simple. You write one line code and GLCM, GLRLM features are calculated. So if you are, these are the texture analysis feature. If you want to analyze the texture, then we can extract either histogram or GLCM, and then local features. Local features means suppose this is the image. So out of these images, some areas are local. Suppose we want to identify this area. So local features are there. This, for example, is this local binary pattern. Model-based feature, stochastic fractal model. Transform-based, very popular this wavelet. And you may also discuss these wavelets in wavelet, Fourier, Weber filters. So these are the transformers. They will transform a image and we can access histogram oriented features, Hawk features, co-Hawk features, Fog features, R features. So what these are the different features extracted from any image. And again, this is not what I read from the literature. This is the list. There are many more features. So like these R features, Hawk features. So library is available. Scikit-learn library is available. We'll apply the Hawk feature, pass the image, and apply the Hawk feature. It will extract the features from the attribute. Okay. So these are some features. This is the outline, simple outline, how we use like fruit classification. So different images are there. We will extract the feature on the training. Now, different machine learning models. So here we will use 4 models and KNN, decision tree, naive-bayes, and support vector machine. So I will give, because each model will take at least 1 hour. There is some mathematical, some examples are there. So I'll try to summarize this model, concluded into 1 or 2 slides. So K nearest neighbor, its name sum is K nearest neighbor. So how we'll classify? If suppose these are the data points. These are the data points or these are the classes. 3 classes. Suppose I have formed 3 groups in this class on the basis of like one female, another PhD scholar, another are MTech scholar, like this, for example. If someone will come, so it will find its nearest. अगर कोई female है, okay, so who will be the nearest female group? अगर वो male है, so then he or she, he has to calculate the distance from these 2 sets. So distance क्या होगी इसमें? It's whether it is research PhD scholar or MTech. अगर MTech scholar है तो MTech वाला group join करेगा, PhD scholar है तो it's simple. Similarly, K nearest neighbor means the classification decision will be based on our neighborhood. So first we have to identify the neighborhood. Like here you can see these 3 types of data. Yeah, one more thing, disclaimer you can say. In real life problem, situation is not like this. One group is there, another group is there, another. Okay, you have to do lot of things to achieve the desired result. But in real life it is not. But for example, we have to clearly understand the thing. So here 3 different colors are there, and we want to classify this point, whether this point should belong. So here we can visualize, but it is in practical situation not possible. What will be the difference? So in principle, what we'll do, we have to assign the color, whether this black symbol will get, black cross will get red, yellow or green. So we'll calculate the distance, and when we'll calculate, so how many? One neighbor, and here 3 neighbors. So it will form a neighborhood of this. And on the basis of this neighborhood, maximum is red. So that's why it will get the red color, or its class will be decided by its neighborhood, vicinity of the neighbor. And this way, this research type of algorithm is known as K nearest neighbor. K is number of neighbors. So जो highest value होगी K की, उसके हिसाब से उसका उसकी belongingness to which particular class it will belong. अब ये how will decide? So obviously K nearest neighbor is simple. There is no training in this algorithm. The whole vector will be stored in memory. That's why it is also known as lazy learner. Why it is non-parametric? Because it will not learn any parameter. Its training will be decided, or its performance will be decided by number of samples. So there is no training. The whole sample will be stored in memory. If you want to classify any data point, then we have to calculate. The distance, and on the basis of this distance, so different distance functions are used, like Euclidean distance, Manhattan distance, then for this Minkowski distance, then Hamming distance. Okay, so different types of distance. Which distance will be used? The important thing is not how many distances are there. The important thing is when to use which distance. By default, we cannot use Euclidean distance. Okay, so this decision is important. Different type here you can see how this what Manhattan distance means, what Euclidean distance means, and what is one is Mahalanobis distance. So there are different like Manhattan, Hamming distance. If your data is of binary in nature, then we'll use the Euclidean distance scale invariant. Scale invariant means if there is large number, then the distance will be calculated as large. इसके अलावा there are, this is not the exhaustive list again. Just suppose you are working on map where we have to calculate the coordinates. कौन सी distance use होती है उसमें coordinates के लिए? So for everything, what type of data we are using? Longitude, latitude, coordinate means जैसे one location is defined by its longitude and latitude, and we are calculating the distance between. So Earth is sphere, not spherical, not spherical or elliptical, so not plane. So their distance is different for to calculate the distance to point on Earth. So this is the basic how this algorithm will work, and what are the different types of distance measures are there, and which distance measure it will depend on the context. One more thing, it will store, no training is there, it will store the whole data set, and on the basis of this. The next is base, this naive base. Naive base, and this naive base classifier is based on Bayes theorem. Why this naive base is known as naive base? If it is based on Bayes theorem, then why it is known as naive base? Anyone? No, Bayes theorem, so it should be Bayes classifier. What naive base? We'll come to that. In Bayes theorem, this Bayes theorem is based on probability based. There are three types of probability: marginal probability, conditional probability, and joint probability. Okay, and here we will estimate two things. Just suppose this Bayesian learning is like first you will guess. Okay, first you will guess something about me, and then you will guess something, and you will make an impression. When you will get some more evidence, okay, you will get some more evidence, then your perspective will change. If you will get some more evidence, then your perspective will be changed. So this Bayesian learning is work like this. So initially we will estimate something. If we get evidence, again we will get evidence. Like जैसे suppose आपने किसी को देखा and you उसके long hair and you have taken decision this is a female. Okay, on the basis of long hair, you जैसे कई लोग खड़े हुए ऐसे करके किसी के पीछे लंबे long hair है, and you have guess prima facie क्या guess होगा आपका? It's a female. Why? Most of the time, females have long hair, but you may not be 100% correct. You may not be 100% correct. When you will be 100% correct. So what will be the way of? So this is the how probability. This is your you can say the guess or probability. So how you will reach to the conclusion? You will collect some evidence. On the basis of evidence, your probability will change. So like here, in this way, this Bayes theorem will work. There are three types of probability: marginal, conditional, and joint probability. So here the simple example, here 20 red ball and 40 green ball, and suppose some new point will come. So on the basis of, because greens are more, so we will guess that this new will belong to the green, because green numbers are, जैसे how will decide the branch or elective subjects? How will decide the branch or elective subject? सब कंप्यूटर ले रहे हैं, कंप्यूटर सब ये डेटा साइंस ले रहे हैं, डेटा साइंस ले रहे हैं, सब ये ले रहे हैं, ये ह्यूमैनिटीज वाला कोई सब्जेक्ट ले रहे हैं. So it's like this. So this is our simple guess. Here you can see this. This is known as prior probability. Prior probability means we know that greens are more. Eyes have weight. Eyes have weight. Parliament में नहीं होता. Eyes have weight. Eyes have weight like this. So if greens are more, then point will belong to green. Okay. So this X will belong to green. Then we have to likelihood. Likelihood क्या होगी? No, this is not the way. First we have to identify the vicinity of this point. We'll draw the vicinity line. We will draw the circle. In this distance, how many points? So when we'll define the vicinity. Okay, here what we are doing? We are defining the vicinity. Vicinity defining means we are giving some more evidence. So this is the, on the basis of this vicinity, your decision will change, because within this vicinity, 3 are green. One is, 3 are red, 1 is green. So this is known as likelihood. So prior probability will indicate this point will belong to green, and this likelihood will indicate this point belong to red. So we will, so in Bayesian analysis, the final classification produced by combining both source of information. कहने का मतलब है कि when we receive any guess, it will work as a evidence. जैसे वो long hair is a male, female, so we will call them. Suppose आवाज है, तो अगर जैसे आवाज से आपको कंफर्म हो जाएगा, जरूरी नहीं है कोई फीमेल भी मेल की आवाज निकाल सकती है, मेल भी फीमेल की आवाज, अगेन यू आर नॉट 100% श्योर. होता है ना, मिमिक्री करते हैं कई लोग, कार्टून्स में आवाज देते हैं तो इट साउंड कैन बी प्रोड्यूस. फिर हमको एक नया एविडेंस चाहिए टू रीच द कंक्लूजन. ये सर्टेन होना है कि वेदर इट इज फीमेल और फीमेल, लाइक दिस. सो समझ में आया किस तरीके से हम इसमें मूव करते हैं, मींस व्हाट इज द वे ऑफ वर्किंग. सो दिस इज द वे ऑफ वर्किंग ऑफ बेस, वेयर वी हैव टू कंसीडर प्रायर प्रोबेबिलिटी एज वेल एज likelihood, and both source of information will be combined together to estimate the posterior probability, and we will combine both to estimate the probability. This is the rule, or you can say this is the posterior probability class. ये class है, ये feature. ये which probability? Conditional probability. And ये क्या है? Likelihood है, ये features है, ये class. So this is known. Known means हमको एक टेबल दे रखी है, features and class. x1, x2 belong to c1. Then this tuple will belong to c2. And ये class prior probability, and this is total probability. So this formula is known as Bayes theorem basically. And how it will work? Calculate the prior probability, compute the probability of each class in the training data, calculate the likelihood for each class, compute the probability of observable feature given in the class, and then apply Bayes theorem to combine the prior probability and likelihood to estimate the posterior probability. Why this is known as naive-Bayes NB? Because here there is one assumption of this algorithm. This algorithm will assume all features are independent. Like independent means, just suppose we are measuring the performance of any student, and we are taking some features. Like we are taking its JEE marks, its 10th mark, 12th mark, okay, and semester marks like this. So we are extracting many features. Similarly, we are taking height, we are taking weight. Okay, in this way we are forming a feature vector. So the precondition for this algorithm's one assumption is very naive. Naive means ekdam innocent. Okay, no सीखिए एकदम जिसको means much have detailed idea about the situation. So that's why it is known as naive-Bayes. Bayes, naive, because of its assumption, core assumption of this algorithm is independence of features. But it is not in real life, features are not independent. जैसे suppose weight, height weight है, तो there is a correlation between height and weight. अगर height ज़्यादा होगी तो probability आपका weight ज़्यादा होगा. So sometimes feature independence may not be clear. If your feature are not independent and you are applying new weight, then you may not get the desired result. ये algorithm कब काम करेगी? उसका नाम ही है new weight. The feature independence. Depend होंगे. Okay. So one algorithm is decision tree. It's a rule based. Suppose this is our training data, and from this training data, first type of tree is generated. So this tree will be converted into rule, like student no, income high, age less than 30, then buying decision of computer will be yes or no. So in this way, it will form the rules. Okay. So this is the example of tree. How decision trees are generated from the training data. This is a toy example. But in real life, you have some features like here in this case we are taking age, income, and rating. Generally, we use this example to by pen board. So that's why this is a very small example. And this will convert into. Now, what is the point is what? Point is tree-like structure. So decision tree is not a single algorithm. Decision tree is a family of algorithms. And what are the main algorithm in decision tree? कौन सी algorithm होती है decision tree में जो popularly will use? Popularly, knowingly or unknowingly, we are using. So sometimes I use decision tree. Which decision tree? Decision tree is a family. Like I am a student. किस class के student? किस course के student? So there are different algorithms like ID3, C4.5, C5.0. If anyone is using this Weka-like software, so in this Weka, this decision tree is implemented as a J48. Weka is implemented in Java. So some copyright issue with C4.5. So directly they cannot use C4.5. So C4.5 is implemented as a Java version 8. So Java J48. So J48 nothing but C4.5. CART scikit-learn में कौन सी algorithm use होती है by default? Which algorithm is used? If directly we are using scikit-learn decision tree algorithm, then this is the CART, not C4.5. I have I have seen in many papers, people are saying that they use the default decision tree of this scikit-learn and they are writing the description of C4.5. Default is CART, classification and regression. There is a reason why this CART is used. So what is the difference between all these algorithms and many more? These are the predominantly used, popularly used, and the difference is the only difference is like this tree is formed. So which feature will be converted into root node? Okay, out of this feature, age, income, student, rating. How you will decide which feature will be the root node? How you decide? So learning decision tree is only this thing. There is no mathematics behind it, and it is you may be heard about the entropy. Entropy. So entropy concept is used. Which entropy? Shannon entropy. Again, there is a some reason why Shannon entropy. There are earlier I was also in impression that only one entropy is there, but when I checked, so 20, 30, even 50 entropies are there. At least I checked 10 to 20 entropies are there. Different entropies. Out of this Shannon entropy is used, and this entropy is a measure of impurity or disorder within the data. So the main important question is which one or which feature will be selected as a, why this student is selected as a group, why not age, why not credit rating. So this will be decided by the entropy. We will measure the entropy of each and every. And this is known different decision tree, like in IIT algorithm for this root selection or split criteria बोलते हैं. How to split? How to split? First split, then second split successively. How to split? How to perform the split? And this splitting criteria is different. So in algorithm, one difference only. Different algorithms will use the different splitting criteria. Like IIT algorithm, now IIT is not used anywhere. IIT algorithm will use information gain. Information gain. ID3 will use information gain, but there is a problem with this measure. This information gain is biased towards multi-value rating. Multi-value, if we will select a serial number column, then every time serial number will be the root node. If there is a more unique value, then it will favor to the unique value. So in C4.5, there is improvement. In place of information gain, this will C4.5 use the gain ratio. Gain ratio क्या करेगा? It will normalize. अगर multi-valued attribute है, so it is not necessary that always multi-valued attribute will be selected as a root node or splitting. So, but there are some problem with this. Tends to prefer unbalanced splits in which one partition is much smaller than the other. So tree आपका uniform नहीं. तो एक algorithm होती है, which is known as CART. इसमें use करते हैं Gini index. Statistical measure है, very from 1800 something. This measure is used. So this CART is by default implemented in scikit-learn. If you are using scikit-learn, yes, we can use C4.5, but you have to change the parameter. If we'll select the entropy, then C4.5. ID3 is not used. So CART. So this is the decision tree. So decision tree is different entropy measures or splitting criteria. Splitting criteria, entropy is the core. These two, first two, while in third we will use the Gini index value. उसमें ज़्यादा होना चाहिए और ये Gini index की value कम होना चाहिए. So how we'll do it? We will measure the information gain or gain ratio of each feature. और जिस feature के लिए ज़्यादा आएगा, numerical value सबसे ज़्यादा होगी, that will be of root. फिर कब तक करते जाएंगे? जब तक कि हमको सब में यूनिफॉर्म नहीं, there is no possibility of further division. सब में yes yes या no 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 ही मिल जाता. जैसे हमको सब में yes मिला, will stop. But ये तो toy problem. Real life problem, this tree maybe grow to like anything. So there are some pruning strategies are there. Tree pruning strategies, we can stopping criteria are there. So the whole story is available. Quickly, I will summarize one more algorithm, and this is the SVM support vector machine. So support vector machine is basically discriminative, and how this algorithm will work. Again, this is the ideal case. We are clearly linear. So it will it will draw a hyperplane between the samples. It will draw a hyperplane, like you think in more simpler way. If some data are there, like we are all are VR data, and anyone wants to classify us through SVM. So how it will apply the SVM? He will come with some bar. Put a bar here. It's a resource person versus attendee. Now it will put another bar here, then classify. So there are many discriminative lines are there. Hyperplane बोलते हैं. Technically they are known hyperplane. What is their significance? If your data is one dimensional, then hyperplane will be point. If your data is two-dimensional, then hyperplane may be of a line. If your data is three-dimensional, then your hyperplane may be of plane. If your data is four-dimensional, then your hyperplane may be of three-dimensional. If your data may be of n-dimensional, then your hyperplane may be of n minus one dimension. Okay, so hyperplane is basically a technical term, but this hyperplane is a separating line of plane which is used to separate the data points. So how this algorithm will work? But many hyperplanes are possible. One can put here, multiple are there. So which one will be the maximum distance? So for that we have to identify the boundary data points, and these boundary data points, like these data points, are known as support vectors. So support vectors are what? These are the boundary data points. And with the help of, so how we'll know the support? Randomly we'll draw the line and we'll try to optimize. So this is our how the support vector machine. But there are different forms of support vector machine, and this is known as, one is known as hard margin support vector machine. Hard margin support vector machine means this is also known as maximal margin support, because here we are trying to hyperplane. We'll choose the hyperplane which will give the maximum margin. If suppose this is our hyperplane, and if any of the data point will lie within this, then this algorithm will not work. This is known as hard margin support vector. If any of the single data point lie between this, then this algorithm will fail. So what we'll do? We will add tolerance for the error. इसके objective function में will add, and this is known as soft margin. If some data point lies in this, because ideally ऐसा नहीं हो सकता. There is no possible in real case that this data will be separated like this. You will get the, theoretically it is possible here for understanding point of view, but real time data it is not possible. So the another version, more we can say that tolerant version is soft SVM, soft margin SVM. Soft, if some data point lies, so then your performance will be degraded, but your algorithm. Again, the major limitation, this algorithm will work only for linearly classified problems, where we can draw the line. It is not possible. And such type of support vector machines are known as primal form. Primal form. So primal, it may be of hard margin, it may be of soft margin. And the objective function of this, again, this function is divided in every machine learning. For every algorithm, there is mathematics. So we will form this in form of weights transpose of this. We will form this function and we will optimize this function. So what will be the result of this? It will give you the maximum separating hyperplane. Okay, this we will perform the optimization on this function. So it will give you a line. Which line? This is desired here. But this algorithm is work only for linearly separable data. If your data is not linearly separable data, or you can say the real-time data, like this. How you will draw the hyperplane? Anyway, it is not possible. You cannot draw. Then real SVM will come to picture. जिसको हम कर्नल SVM बोलते हैं, या जिसको dual of SVM बोलते हैं. SVM means, so what it will do? It will use some projection technique. कुछ चीजें होती है ना जो जैसे सपोज हमको नहीं दिखती, जैसे साउंड है, तो सम एनिमल्स देयर जो डेसिबल पावर होती है वो अलग होती है. If we are not able to see anything or we are not able to smell anything, but dog will smell something foul here. Or similarly, so what they will change the projection of data, and for that they use the kernel function. Like I have some data, I cannot draw. This is the plane. I cannot draw line in this. I cannot draw either line or plane in this data. So what we'll do? I will project. Like I will throw it into larger space, and then I will put a plane. Like if their weights are different, talk about ball. Okay, क्या बोलते हैं, कांच की बॉल आती है, कंची, सो अलग अलग वेट की कंची, उसको सेपरेट करना. यू आर नॉट एबल है, सो वी विल, जो हेवी है वो, यस, एट दैट टाइम वी कैन. तो ये एनालॉजी है. व्हाट इट विल डू, we will apply some projection technique, and these projection techniques are known as kernels, and this kernel will change the space, ये 2-dimensional 3 में, and then we will insert the hyper. ये manually नहीं होगा, there is some mathematics again, we will take the dot products, okay, but for understanding point of view, it will not so easy, there is lot of mathematics behind this, but we have to know the working of the algorithm. Then it will be, if we apply one kernel function, then it will give result. If we apply another kernel function, then it will give result like this. Okay. So kernel functions, kernel क्या होता है? Kernels are the projection function, mathematical function, and these are some linear kernel. Linear kernel means polynomial kernel, Gaussian kernel, sigmoidal kernel. Okay. And other kernel, spherical, wavelet, Bayesian. कई सारी kernels होती हैं, mathematical functions होती हैं. तो ये क्या करते हैं? Project करते हैं डेटा को. जिसको हम 2 डायमेंशन में नहीं कर सकते, उसको 3 डायमेंशन में, 3 में नहीं कर सकते उसको 4 में करेंगे, 4 को नहीं कर सकते उसको 5 में करेंगे. एक थ्योरी होती है ना, जैसे कोई बोलता है एलियंस आते हैं, कोई बोलता है मुझे भगवान दिखते हैं, हो सकता है किसी को दिखते हो, हम नहीं देख पाते. लाइक दिस, ये हमारे, इट्स बियॉन्ड आवर इमेजिनेशन, बट यस, इट्स पॉसिबल थ्रू मैथमेटिकल प्रोजेक्शन. तो कर्नल्स क्या करेंगे? कर्नल्स विल प्रोजेक्ट नॉन-लीनियर डेटा टू सम हाइपरप्लेन. Hyperplane means more than 2 dimensions. You cannot visualize, but here, but these pictures will give you some tentative idea. Okay, some intuition. And here we will perform the dot products, and then we will classify. So this is known as the dual of our SPM. So this is I just cover this because it is too difficult to cover in short span. इसके पीछे पूरा एक मैथमेटिक्स है. It will take 2-3 classes. डॉट प्रोडक्ट्स क्या होते हैं, कैसे हम परफॉर्म करते हैं, एक वेक्टर है, वेक्टर डॉट प्रोडक्ट्स ही होता है यहाँ पे, डॉट प्रोडक्ट होगा और उनका उसमें ये सब मैथमेटिकल टूल्स, they are highly useful in this understanding or implementing of this machine. अब हमको इसमें मींस programming point of view, experiment point of view, their library is available, directly we can call linear. आपको सिर्फ पैरामीटर चेंज करना है, linear है ये, आप you can use any kernel, convenient, but you have little bit idea how these kernels will work, what is their intuition. Okay, then how to measure, I think sir is when I joined, sir is saying about this confusion matrix. For every classification, for every machine learning model, some model evaluation parameter. There are 2 types, like some error based or some are this for classification. So classification results are one data structure, you can say the confusion matrix is created. Suppose we have taken 100 samples, and these 100 samples will be divided into some samples. One is actual, another is predicted. So how many actual, how many predicted? On the basis of this, true positive, true negative, false positive, false negative. So it will form a 2-dimensional in case of binary. In case of multi-class algorithm, it can be of any type. तो ये values होगी. जैसे suppose, for example के लिए 10 samples मैंने ली और 10 में से 2 जो हैं वो true positive हैं, कुछ false positive हैं, कुछ true negative है, कुछ false negative. So it will be organized like this. The actual है, it can be of anything. Don't try to remember this algorithm, this confusion matrix. Okay, it's not confusion matrix. You can, the actual can be here. Sometimes you will find that actuals are here, predicted are here. So if actual means, what is your class label? If actual are predicted as the same, like if actual is positive and predicted is also positive, then we'll say this is true positive. If actual is positive and predicted is negative. So what will it will be? False. What? If actual is positive and predicted is negative. If actual is positive and predicted is positive, then it will be false, false positive. And if actual is positive and predicted is negative, then it is false negative. Because ये actual positive है और predicted predict क्या किया इसको? Negative. तो ये negative is false negative. Similarly, if actual is negative and predicted is positive, so then false positive. If actual is negative and predicted is negative, true. So the sum of all these be the total number of samples. हम इसमें क्या करते हैं एक्सपेरिमेंट के लिए? जो डेटा सेट ट्रेनिंग सैंपल, एक ट्रेनिंग सैंपल होता है, एक वैलिडेशन होता है और एक टेस्टिंग. जैसे 100 सैंपल है हमारे पास, 100 रोज, तो वी विल नॉट यूज 100 रोज फॉर ट्रेनिंग. We will use generally some validation techniques are there. So 70% is used for training, 10% is used for validation, and 20% is used for. कोई भी आप में से बता सकते हैं क्यों यूज करते हैं हम वैलिडेशन? What is the significance of validation? Yes, to check or to tune the hyperparameters of the model. There are two types of parameter and hyperparameter. Anybody can differentiate what is parameter and what is hyperparameter? What is the difference between parameter and hyperparameter for any model? Yes, hyperparameters are actually hyperparameters are used. Their values will contribute in the performance of model. They are not essential part of model. If will not, their default value is okay. Then if we want something, some more performance, then we have to optimize that. So this is the logic of hyperparameter. So parameter is a essential part. We have to give some value. Hyperparameters are optional, and we have to, when we use tune this for betterment or for more performance. So by this confusion matrix, we can. There are three types of sets we use: training set, testing set, and validation. Validation is used for parameter tune. We have test the model, and if we want to tune the parameter, we can use the validation set. How means this, which for which parameter value this model is working best, like this. For this we use the validation set, and then we can perform the test. So on the basis of these four values, we can derive so many things, like accuracy. Accuracy क्या होगा? The correctly classified samples divided by total number of samples. So what will be the correctly classified sample here? True positive and false positive. True negative. Sorry. True positive and true negative. So true positive plus true negative divided by PPFP TNFN. This is known as, and 1 minus accuracy is known as error. अब now precision. So precision is what? Precision is how many what percentage is correctly classified, how many positives are correctly, what fraction of positives is correctly predicted as a positive. So TP divided by total predicted positive. So total predicted positive will be true positive plus false positive, true positive plus false positive. This is known as precision. Recall is actual number of positives divided by total positive. So actual number of positive, true positive, false negative. Yes. True positive divided by TP upon Fn. This is known as recall. Recall is also known as sensitivity. Okay, sensitivity and recall is same thing, or one more name is true positive rate, TP upon TP plus Fn. Similarly, we can find the specificity. Specificity is also known as TNR, true negative rate. Tn, true negative rate, Tn divided by Tn plus Fp. Okay, so in this way we can derive many PPV. This precision is also known as predictive positive value, PPV. Sensitivity, recall is sensitivity, recall, and TNR. Sorry, PPR. These are same. Specificity is true negative rate, Tn upon Tn plus F. So we can derive these measures. Then the important thing is not how to derive the measure. Again, which measure is used for which type of problem. So here, these are some cases. For example, जैसे so stock market crash prediction. Imagine a situation where our model has wrongly predicted that market will not crash, and instead it crashed. The people have to go through a lot of losses in this case. So which measure will be useful? Which value will be useful here? चलो इसको मैं और एक दूसरे और सिंपल तरीके से रखता हूँ. जैसे सपोज यू हैव डिप्लॉयड अ सर्विलेंस सिस्टम, ऑटोमेटिक सर्विलेंस सिस्टम है, कैमरा बेस्ड. It will put surveillance on crowd, and you have to identify some suspicious person. Crowd में रेलवे स्टेशन वगैरह जहाँ सर्वेलेंस सिस्टम होता है. So what you decide? What it should do? Should you want precision or you want recall? किस मेजर पे आप फोकस करेंगे? Why? Why? सपोज अगर आपने प्रेसिजन यूज नहीं किया और रिकॉल यूज किया. प्रेसिजन यूज किया मतलब प्रेसिजन में क्या होता है? टीपी अपॉन टीपी प्लस एफपी. व्हाट इट मींस, अगर एफपी की वैल्यू ज्यादा होगी, टीपी अपॉन टीपी प्लस एफपी है तो टीपी टीपी तो सेम हो गए. अगर यहाँ एफपी की वैल्यू ज्यादा है तो प्रेसिजन की वैल्यू क्या होगी, है ना? जैसे जो न्यूमरेटर है डिनोमिनेटर ज्यादा होगा तो ओवरऑल रेशो कम होगा. क्या होगा इसमें? प्रेसिजन कम होगा. सो अगर फॉल्स पॉजिटिव हम कम करना चाहते हैं, फॉल्स पॉजिटिव कम रखेंगे तो क्या होगा? प्रेसिजन हाई होगा. फॉल्स पॉजिटिव अगर कम होगा तो प्रेसिजन हाई होगा, और अगर फॉल्स पॉजिटिव ज्यादा होगा तो इसका क्या मतलब है? जैसे रिकॉल, हाई रिकॉल मतलब रिकॉल का फॉर्मूला क्या होता है? टीपी अपॉन टीपी प्लस एफएन. फॉल्स निगेटिव, अगर फॉल्स निगेटिव कम होगा तो रिकॉल ज्यादा होगा. इसको अगर हम इन जनरल टर्म्स में टेंटिव करें, अगर सपोज कोई व्यक्ति, इफ समवन इज नॉट सस्पिशियस एंड आपका सिस्टम उसको फ्लैग कर देता है कि ही इज सस्पिशियस, देन व्हाट विल हैपन? उसकी फ्रिस्किंग होगी, फिर से फ्रिस्किंग होगी, उसको चेक करेंगे. ओके गुड, आपका डॉक्यूमेंट दिखाइए, सामान है. बट अगर कैंसर के केस में ऐसा हुआ तो यहाँ क्या इंपॉर्टेंट है? रिकॉल इंपॉर्टेंट. देयर शुड बी, ऑल्दो योर सिस्टम में फ्लैग a wrong person as a suspicion, कवर, कोई भी उसमें से छूटेगा नहीं, बट कुछ फॉल्स उसमें आ, तो such type of scenario we use, we focus on recall. बट अगर कैंसर का केस, कैंसर डिटेक्शन में अगर किसी को कैंसर नहीं है, तो आपके सिस्टम ने उसको डॉक्टर ने उसके भेज पॉसिबल, सिस्टम में फ्लॉ, वहां रिकॉल नहीं। अगर एक छूट गया कैंसर का, हो सकता है वो सेकंड ओपिनियन में या सेकंड स्क्रीनिंग या precision. What I mean to say is precision and recall will depend on the problem. जैसे फॉर एग्जांपल ये इसमें एग्जांपल क्या होगा, ईमेल वाला स्पैम डिटेक्ट। अगर सपोज कोई आपने यहाँ क्या यूज करेंगे, आप प्रेसिजन यूज करेंगे कि रिकॉल यूज करेंगे? लगता है आपको समझा नहीं पाया मैं प्रेसिजन रिकॉल का कॉन्सेप्ट। आया समझ में? ईमेल में क्या यूज करेंगे, जैसे सपोज अगर हम रिकॉल यूज करेंगे तो क्या होगा, कुछ स्पैम मेल है जो हमारे ईमेल जो क्या बोलते हैं उसको इनबॉक्स में डिलीवर हो जाएंगे। Why we use recall here? Yes, if we use recall here, then there is a possibility some spam email may deliver to our inbox. आप क्या करेंगे, उसको फिर से उसको मैन्युअली स्पैम मार्क कर देंगे। Yes, but if we use in place of precision, in place of recall, if we use, then there may be possibility that you get some important email, and this email may deliver to your spam folder. That email. Yes. Or is not daily communication. IIT Bombay. तभी आपने never mail to the IIT Bombay. There is no communication with your IIT. So probably this is the first time you are getting mail from IIT Bombay, and that to be equipment or PhD sale or some complicated email is there, and possibility it may be delivered to your. So what we should consider here? Recall. एक ईमेल अगर आपको फ्रेंडशिप का आ गया तो उससे फर्क नहीं पड़ेगा, ओके, बट अगर आपका इंटरव्यू का मेल वहां पर चला गया तो कॉस्ट विल बी। पॉइंट इज व्हाट? पॉइंट इज we have to take a judicious decision which we apply which case, not like that मैंने देखा लोग यूनिफॉर्मली कुछ भी लगा रहे हैं, जो भी समझ में आ रहा है उसको लगा रहे हैं। why there is no rationality, why they are, and again what is your class of interest, पॉजिटिव क्लास क्या है, नेगेटिव क्लास क्या है, for doing cancer detection then wrong. Okay, I think समझ में आया सबको? And then in some problem this precision and recall, because both are, there is a trade-off between precision and recall. If will improve precision, then recall will be down. If will improve recall, then precision will be. In some cases we need both precision as well as, in fact in most cases except some critical cases we need both. Critical cases like this cancer detection focus only on whatever be our recall, don't care about recall. So if we require both, then we will use a new measure which is known as F measure. This F measure is basically a harmonic mean of precision and. Why not algebraic mean? Why harmonic? Anyone? कितने टाइप के मीन होते हैं आपके? अभी तक आपने कितने मीन के नाम सुने? अरिथमेटिक मीन हो गया, और ज्योमेट्रिकल मीन हो गया, गुड, और हो गया, मुझे कुछ याद नहीं आ रहा है। Okay, means you are agree there are number of, at least I can give guarantee 3-4 types of means are there, like arithmetic mean, geometrical mean. But why we are using harmonic? Anyone? Because we are interested in both precision and recall. If suppose precision, if we are using arithmetic mean, precision value is high, then your arithmetic mean will be dominated by that high value. If your recall value is high, then, but you are not interested in domination. You are interested in equal contribution of both the mean. That's why we consider the geometrical. किसी की वैल्यू हाई कम है उससे ज्यादा नहीं पड़ेगा. It will reflect to both the precision and recall will be equally contributed. Why we use अभी एक formula है पूरा, but for the time being you just keep in mind F measure is a where we should consider where precision and recall both are equally important, and we do not want to allow to dominate any of the measure to the whole our one measure. That's why we use the harmonic mean. Okay, then this sensitivity, specificity, TM. One more thing is ROC curve. Okay, ROC curve is like this type of curve. So in this ROC curve, what we'll do, here we will take for each and every, and we use the threshold value. And this threshold value, on the basis of this threshold value, your curve will look like this. So ideal curve क्या होगा? Ideal curve will be look 50%. This line is the baseline. ये automatic जैसे guess है, इसमें कोई classifier लगाने की जरूरत नहीं. It's if any curve is below is this, then there is no use. Possible ही नहीं है. ये random है. Random guess भी 50%. These are the difference. And if any classifier the curve is high, then it will be. So how to calculate this ROC? This ROC will be calculated. You have to define the threshold for each and account TP, TP, FN at every TPR, FAR, and then we will. And practically it will be like this zigzag. If our data is vary, then in that case we will get the smooth curve. So this is also the one way. Then many more measures are there, but yes. Okay. So hope you will get something in this machine learning. What is the introduction of machine learning? And for implementation point, there are a lot of facilities are there. Even scikit-learn, you will get each and everything, whatever you want to do. Now quickly come to the our problem. And time हो गया क्या सर? थोड़ा सा I will take 20 minutes. और ये मशीन लर्निंग का लेक्चर हो जाएगा. Okay. Next audience है हमारी सर. So yes, yeah, you may be aware about the different this medical imaging modality. So these are the different tests like radiology test, X-ray, computers. You may be aware about all these things. So what is this medical imaging? So medical imaging modalities are capture detailed image of human body, internal structure, organs, and tissues, diagnostic and treatment purpose. Why we take this test? And each modality like X-ray, so there are unique features of X-ray, MRI, there are unique features of MRI. Each test has its each modality has its unique principle, strength, and application. It's not like that ki this test is universal. Okay, so we will use only one test. And these are the some examples. And nowadays, this medical analysis, image analysis are used to aid this diagnostic process. And this diagnostic tools are used to determine whether patient have acute condition or chronic illness or what is his current state of health. But what is the problem with this medical imaging? First problem is these medical imaging equipment are different. They are not our normal cameras. Okay, like if someone asks you take your MRI, so we cannot, maybe your camera may be of high resolution, but we cannot take the picture of it. These are totally different devices. Their technology, their principle are totally different. Okay, so here there are many pre-processing techniques but we'll take a simple look. Like here you can see these are the brain MRI. And these three different head MRI scans, and all the same image, unprocessed, same image, same data, different visualization with different contrasts. So the point is, they are different in the way the grayscale are visualized. So these MRI, CT, they are required with medical imaging equipment, which is substantially different than the normal our photo camera. The major difference is the fact that the gray values are measured on different scale. Like computers, we use 256 color scale, the depth is 256 pixels. But here, like in MRI, voxel intensity depends on the receiver gain of MR machine, which again is impacted by many factors such as magnetic field strength, vendor type, pulse sequence, but can be in range of 0 to multiple. हम जो कंप्यूटर में इमेज क्या होती है 0 to 50 to 55 ये रेंज होती है, उन्हीं के बीच में we will decide the color for every pixel, but here it may be of 0 to multiple thousands. So having this large number of intensity values poses some challenge. Neither our eye nor our computer allows to appropriate differentiate such great details. So what we use some image contrast, or you can say the image enhancement technique, and here this is one image enhancement technique. I will not go to detail, but when we apply, so this allows this image enhancement technique. If we suppose, because this brain MRI, we want to focus on some special tissue contrast, or for example, if we interested in soft tissue such as gray and white matter, so we choose window. This is the technique for this windowing is a technique. क्योंकि otherwise this 1000 numbers को हम कैसे करेंगे? So we will use this image for this image enhancement. We use the window. So if we want to see the background noise, we try to focus on intensity value representing the background noise optimized parameter. So here we can say the window level for only visualizing the highest intensity. In second, motion artifacts become visible, and third, good contrast between white and gray matter. So what it means? It means depending on our need, in what portion of the image we want to focus, we will. So there are different softwares are used to visualize. The doctors, it's not like X-ray image. So for MRI, the different softwares like first of all, different this DICOM form, NIFTY form. So images are stored in this form, and these forms are these softwares are compatible to this image form like IIT Snap, FSL Lens, 3D like image. These are the software. Like this, doctors will see with the help of this by right clicking, it can identify the region. So in this way, what it means for medical imaging, especially for MRI, first of all, how to enhance or adjust the contrast of image. So different medical imaging tools are. These are three-dimensional tools, and depending on, because simply we cannot, like image processing, simple image processing, we cannot do it. Okay, and then only, because ultimately we are going to extract the feature. If region is not identified properly, then how will extract the feature? So now, what is Alzheimer? So Alzheimer is basically one type of dementia. Okay, or we can say the progressive neurodegenerative disease, and that affects our cognitive ability. Personality. Cognitive ability means like disturb our identifying capacity, our memory. Okay, so in this way, it will adversely affect our health, and slowly this disease will progress. And there is no way to directly cure this disease, because when we identify, like sometimes if we are not remembering something, so like, yeah, we are doing so many things, so we may be puzzled, that's why we are not remembering. So in this way, its stages progresses with time, and after some time, it will means subject may lose its memory, or total not be remember anything or like this. So it's cognitive impairments are there, and it will severely affect. So what is the effect of this Alzheimer? The brain shrink, and the one part in our brain which is known as the hippocampus. Hippocampus, and the hippocampal side decrease, and the brain verticals expand as a result of Alzheimer. So memory, reasoning capacity, and the person's gesture to the issue day-by-day activity all deteriorate as Alzheimer disease progress. So understanding Alzheimer, its mild cognitive impairment and cognitive normal manifestation has been one of the neurologist's most difficult tasks in recent years. And different any data set होता है, data set Alzheimer पे काम करती है, okay, they keep a record. Simply you will mail them, define your objective, like I'm doing this research on this. So they will share they will provide the access to their data set, and whatever we are discussing, even most of the Alzheimer paper, generally people use this. So they stored this data in variety of form, variety of images are there, but here we are considering. So Alzheimer, these are the 6 identified stages of Alzheimer, like Alzheimer, dementia. Alzheimer is a one way of dementia. 60 to 80% dementia cases are lead to Alzheimer. Mild cognitive impairment. In mild cognitive impairment, present a small but perceptible decrease in cognitive capabilities containing memory and intellectual abilities. Late mild cognitive impairment, a person is diagnosed with LMCI in later stages of MCI. Early a person can diagnose the initial stage of MCI stage. It is known as EMCI. What is this? These are the stages of Alzheimer. And the main objective is how to classify the stage progression of Alzheimer. This subject is at MCI stage, EMCI stage, LMCI stage, or SMC or CM, like cognitive normal and significant memory. Yes. And this LMCI, either we can consider this LMCI and EMCI, we can say the class of this MCI. So in principle, there are 5 classes: AD, LMCI, EMCI, SMC और CM. Problem में क्या है हमारे पास? 5 classes. We have to design a classifier for this 5. So this Alzheimer disorder detection using MRI images. The texture, structure, and the volume of brain are used to distinguish the healthy brain from the diseased brain. Okay. So first we have to take the brain images and then find out the texture features and volume of, like one property is our hippocampus. The part of brain will be shrink during the progression of this disease. So we will find out the feature form, this part, and different types of MRIs are taken for this structural MRI, functional MRI, this functional MRI, and diffusion tensor imaging, DTI imaging, and amyloid imaging. Amyloid imaging basically a fusion, different types, like one type of imaging will be fused to another type, and it will create a different type of image. So use of MRI images in this disorder. So one is for longitudinal monitoring, tracking disease progression. So periodically we'll take the MRI images, like 1 month, 2 months, 3 months. So serial MRI scan performed over time can be used to track the disease progression, allowing clinicians to assess how disease affects the brain structure and function. The second is early detection and differentiable diagnosis. So MRI can assist in the early detection of Alzheimer. So one way is over the period of time we'll track the disease through MRI, or we can detect it. Here we consider the structural MRI, and this structural MRI can also be performed. There are 3 views: axial, coronal, and sagittal. So out of this, we have considered the axial view of the brain. Means structural MRI can be of perform in 3 ways. So we have considered only the axial view of MRI. And this structured MRI axial view, we have identified these cases, cognition stage like cognitive normal, significant concern, early mild cognition, late mild cognition, Alzheimer dementia. These are the subjects, number of male, number of female. This data is from AD data. Okay, and these are there. This is the subject description. This is their average age. So first we will perform some pre-processing on the image. First is resampling. So resampling process of altering the spatial resolution, size, orientation of MRI image or volume. So why will perform this resampling? Because resampling will improve the image quality, matching the MRI data to specific reference frame or making the data compatible with certain software or analytics technique. Because the source of MRI may be of different, so we have to resample the same size because ultimately we will perform the segmentation and feature extraction. So these are. Then one is known as N4 bias correction. So what is this N4 bias correction? Is technique used to correct the intensity, inhomogeneities or spatial variation in image intensity that can occur due to magnetic. Every machine is different. Okay, and there may be variation there, magnetic field strength and all these things. So due to some bias, possibly some bias may be added to the this output image. And for to rectify this bias, we perform this N4 bias correction technique. N4 is just because of its fourth order polynomial. That's why. So this is the visual representation of result N4 bias correction. So this is also pre-processing step. Then we will perform the skull stripping. So skull stripping is the process of segmenting the brain tissues from the surrounding non-brain tissue. So this is our this image, and we are performing here skull stripping, and this image is only of our interest. Then MRI registration. So MRI registration is crucial step in Alzheimer's disease research and diagnosis. It involves aligning especially mapping multiple MRI images from the same patient across the different. What it means? It means from the same patient, if we take the MRI multiple times, then there may be some variation. Okay, some variation. So this registration is essential, and we'll perform the registration. So the registration can be of different type, like linear, non-linear, or diffeomorphic registration. So here we use the linear registration. And linear registration, there is a tool which is known as flood, and by using this tool we perform the registration. And here you can see these are the what is the purpose of this registration. Suppose this is the first time we take the MRI with this company machine or this machine, second time with this. So these are the different, the vendors may be of different, their manufacturer may be different, their conditions may be different. So or these are the different MRI, same patient MRI, you have to perform the stage progression. Suppose 1 month हमने यहाँ से लिया, 2 second month कहीं और से MRI कराई, 3rd month कोई और से करवाई. Their instrument may be different, their magnetic field strength may be different, their company may be different. So they will perform the registration. So after performing registration, now these images will be converted into this type of images. Okay. This is the code used for this image registration. Now we will perform after image. So after this is the pre-processing part only. First is enhancement, contrast adjustment, then pre-processing. These 3-4. There may be some more steps. Maybe I have included only the essential, very essential what we use. Okay. There may be some other better image quality. Then now come to the core part. we cannot work on the whole image. So we will perform the segmentation. Segmentation means the region of interest. So image is segmented. So there are different segmentation techniques for MRI images. We use this voxel-based morphometry, and this VBM allows comparison of brain anatomy, including volume and shape, between different groups of individuals, such as Alzheimer patient and healthy control. It involves reprocessing MRI data to align the brain. The second is region of interest, ROI analysis. And in this way, we'll perform the segmentation. Now the question is, how will perform the segmentation? So there are tools are available for this. And everywhere we just use a particular library or tool. Like this task, the pre-process image will be given and we perform pre-surfer. We use pre-surfer and this segmentation is performed. Like in this way, the image is segmented into multiple parts. And this is the case of a stage-wise image segmentation, like for so these are the segmented image on grayscale. Okay, so this is the code, not the whole code, the snap of that code mainly. How? So here you will see the page plus Harvard of code and connectivity by libraries were used. Now, segmented images are available. Okay, after segmentation, segmented images are available. Now, earlier we have discussed different types of features. So here we use two types of feature, hog feature and hark feature. So this hog and hark, without going into detail of hog and hark, we use directly the hog and hark library. So these are the different attributes like volume, area, thickness, shape, cognitive assessment, live neurons, demographic information. Out of these features, we use only volume and shape. So in volume, attribute, under volume attribute, there are 10 features. Under shape, there are 4 features. So we extracted hog features as well as hark features from volume and shape. So we use this HOR and HOG for both, like these are this 10 features for HOG and for HOG. And Python. So in this way, this much number of features, like from reason we have extracted, we use the 10 features and this much number of values, like from left hippocampus 144, okay, number of features, shape 29, shape or volume use kiya. So right hippocampus. In this way, the total feature vector. So we have created the feature vector like 173 feature from left hippocampus, 100 feature right hippocampus. In this way, you can add the total number of features. How many features are extracted from these two? If we'll consider all, then the feature set may be of very large. So in this way, the feature vector is created, 10 of volume feature and 4 of shape feature. Now this feature vector is passed to these 4 classifiers. First, this feature vector is divided into again training phase and validation set 70, 10, 20 and passed to the different these 4 classifiers what we have discussed and evaluated the result. feature vector part. Feature vector creation, then labeling, because we already get these labeled images. Otherwise, if you are taking some, if you are collecting images from hospital, then you have to approach to the expert, MRI expert, radiologist for labeling. And again, it is divided into 3. So this will be the, you can say, the general architecture of our feature vector. 2 by 2. Sorry, this n by n the header will be the size of our feature vector. Volumetric and shape feature. 4 classifier. So we'll perform again this feature vector is divided into 70% of training, validation 15% and 50% test. You can adjust according to your requirement, and we'll perform the k-fold cross validation. Okay. Why we perform the k-fold cross validation? Just to ensure that our model is not overfitted. In this way, and these are the reported results for each and every category. All measures what we use precision recall F1 score. Similarly, we use the 10-fold class validation. So this is the average of F1. And we have also taken these are the metrics. So here you will see that these are like CN versus AD, CN versus SMC. So we converted into a binary sort of problem. That's why you may see here we change in number of instances, like instances related with AD, instances related with CN versus SMC, and these are the sample of all confusion metrics, and these are the AUC, ROC AUC curve. Then in conclusion, we can say that the result of ML model may be assistive to doctors up to some extent, but popularly nowadays, even from this work onward, we are using deep learning technique, deep learning and transfer learning. So deep learning and transfer learning, because the amount of this data is very huge. Here we have considered almost 6,000 to 7,000 images. After carefully selecting the images, 7,000 images, more than 7,000 images are considered here. So it will take too much time, and more powers, processing power, as well as better models are available, because ultimately if you are producing something, so you have to compare your work with someone else. And if already reported results are very good, then you are bound to use the same type of technique. But these models are black box model, as I've said, deep learning model. So now not started yet, but we are in initial phase applying this XI model for this. And whatever the major part of this paper is from our first paper. This paper, this is available now technology, and one of my PhD scholars working on it. So he published 2-3 papers, and 2-3 papers are more 2-3 papers are communicated, but mostly on this deep learning or the Markov model. Or thank you. And if you have any question, then please, I will try to answer. Yeah, sir. Informative present, sir. Please, sir, I can have any question, please ask. So there are given, I think, a complete overview of a case study, how to take the data, how to pre-process, and how to use machine learning. So I think every aspect of a classification model has been covered. So I hope those who are beginners might Even I asked him to convert because 6,000 images are too much. So I asked him to select 50 images and change the data to 50 images. So I can share with you, so you can also do the
Exactly. So
These results are producible. Okay, not exactly that scale because reported results. These results are from our published paper. So these results are based on 7,000 images. For experiment point of view, you can perform the same sort of experiment what we did on 50 to 60 images, which means which is manageable in a lab class. You can do it. Yes, it's age related. Means if you are 50, 55 above, then there is possibility of this presence. But it's not visible like within 1-2 years. It will take 8 to 10 years sometimes. That's why this Alzheimer related research stage progression is important. It's not typical case like whether you have Alzheimer or not. It's a stage progression. Your Alzheimer will progress from one stage to another. And detection of this stage progression automatically anyhow we are able to detect.
Just application. सर जैसे हम सर ये मेरा
अच्छा या
हम जब हमारी भारतीय 80+ होती स्पीड स्पीड क्या टेक्निक क्या पर्टिकुलर वो एप्लीकेशन बेस्ड वो
सिंपल कंप्यूटर विजन का एप्लीकेशन है वो कैमरे लगे होते हैं स्पीड ट्रैकर होते हैं उनके साथ ठीक है तो उससे वो आपकी मतलब व्हीकल उससे सीसीटीवी नहीं वो फॉर स्पीड के लिए दे आर नॉट सीसीटीवी दे आर डिफरेंट
नहीं सर आप अभी कुछ सर सेलेक्टेड अभी आए हैं तो देखिए सेलेक्टेड जगह पर कैमरे लगे हुए
दे आर नॉट सीसीटीवी
they are not CCTV actually
they are not CCTV
तो हाई रेजोल्यूशन
कैमरा है they will detect फ्रेम से वो
एग्जैक्टली स्पीड दे यूज टू डिटेक्ट
वो हाईवे पे यूज करते हैं एक्चुअली जो एक्सप्रेस वे वगैरह है जहाँ पे स्पीड लिमिट होती है जैसे आप उड़ीसा जाएंगे उड़ीसा में भुवनेश्वर से पुरी वाला रोड जो है 10,000 फाइन स्पीड लिमिट का एक्सप्रेस वे में भी इतना ही तो वहाँ कैमरे लगे हुए ऑटोमेटिक चालान हाई रेजोल्यूशन कैमरास and dedicated designed for to check the speed.
Games then जैसे डिवाइडर क्रॉस होता है
गाना
डिवाइडर से पास ये तो
हो सकता है वहाँ दे में इंस्टॉल बिकॉज स्मार्ट सिटी प्रोजेक्ट्स हैं तो स्मार्ट सिटी प्रोजेक्ट there are so many innovative things are part of this project. So there may be possibility. I'm not aware. Frankly, I'm not aware about this. But they may install some like sensor.
sensor type.
Yes, some sensors will be installed there. Yeah. There, but so it will be like vehicle counting. How many vehicles are passed from this area? It is very easy. Simple application. Number of counting of vehicles, which type of, how many cars are passed, how many two-wheelers are passed. So like this, it's very easy to count. Doctors बताते हैं. Icon images means they follow particular standard, a global standard, a medical imaging instrument. So there are special instruments by doctors. वो manual नहीं देखते, instrument है. पूरा एक medical का ERP sort of होता है, पूरा इमेज को ट्रैक करना, उसका रिकॉर्ड रखना और उसको कम्युनिकेट करना, एक हॉस्पिटल भेजना। डायकॉन इमेजेस जो होते हैं तो डॉक्टर जो है वो जो सॉफ्टवेयर होता है उससे देख के वो tell you the exact what is on this. But like it's
So
it's
just
not
I
good
will-
for me to comment on that because I'm not medical expert. So our role is our role is to apply the machine learning. Like we are taking data from standard data. Okay, we are not doing anything. They are doing pre-processing. They are categorizing the subject. We are not collecting any data from hospital, and you are not consulted with any doctor. We are doing from our application of machine learning. My area is basically application of machine learning techniques, AI and machine learning. The problem may be of medical imaging. The problem may be of other things. If doctor will explain us each and everything, we will do. In some cases, doctors take help from us that they ask us our problem. Possible. So from their point of view, it was a very big thing. From machine learning point of view, it was simply a 10-line code.
So if you allow, just I will add.
Yes.
I think sir was discussing MRI. You know, you are asking about CT and MRI. So that is actually both are different medical images actually. So CT is having different resolution from.
Our question is which
Prefer
perform should which should
perform first.
or MRI.
Exactly.
So they are
different images. Exactly. So.
But I can not say that first we should take.
Yeah,
CT
of course, there is no
first.
sequence like that. But I usually doctor prefers for CT scan and then MRI. Usually, that's not a traditional way.
There is a side effect of MRI. Once take MRI, it's more than 200 CT scan. In case of CT scan, yes. In case of CT scan, so it's not like if it is necessary, then only doctor.
And it is very costly also, sir. The cost factor is also there. I think one question is from online participant. Who is there? Okay, you can ask your question. Online participant.
Yeah. Can I ask? I'm Aditya. Can I ask a
Please.
question?
Please.
Okay. Sir, I have one query. Sir. Like you have been telling that for the Alzheimer detection, can we implement it using like a deep learning with replacing the pooling layer with the ML algorithm like SVM or KLM? For example, we are using a ResNet instead of the final pooling layer. Can we use an ML like SVM or KNN, something like that?
Yes. From as of now, state of art is these deep learning techniques, and here just as a case study, use case, we demonstrated that this how machine learning because feature engineering is involved and this pre-processing and everything is involved. So from that point of view, here we discuss this use of this SVM, KNN, or for example other machine learning models. But yes, nowadays people are using these different deep learning models and for good result. But as I have shared, they have their own drawbacks. Like these models are not very much explainable. They are black box models. Okay.
Yeah.
So in case of medical image, like if I am patient, okay, or I am relative of patient, so this explainability is equally important. I want to know the reason why I am facing this problem. What is the reason? So this black box model may not satisfy the patient. So in that case, if you're either you have to interpret the result or you have to explain the full why you are facing this problem like this.
Okay. So, okay, sir. Thank you.
That is the ML expert. I think Vivek, you were having some ML related problem in previous session. Sir, you were having some overfitting related question in previous session.
Fitting is very common.
Sir is ML expert. You can you can ask.
What is your problem? Yes, yes. Like to know what other all machine learning model, any of the machine learning model you can use. Provide machine learning. Your data is labeled, then you can use. This Bayesian is. So for unlabeled data, the different types of models are. Or if your data is not labeled, then different types of like any of the clustering algorithm you can use k-mean, k-medoid, KM, or any of the clustering algorithm. Or it's like a Gaussian mixture model. You have idea about the distribution of the data that you can use such type of problem.
So I think no more further questions. So thank you very much, sir. It was very informative session. Let's thanks, sir, for joining us physically. You know, from Nadi Raipur, sir came here just to deliver this talk only. So thank you very much, sir, for this informative session. I hope every aspect of the session was covered, be it healthcare, be it machine learning, or be it implementation of the course. Everything sir covered in this short span of time. So thank you very much, sir. I hope it will help you to improve your research skills further. Thank you, sir. Thank you very much.
Thank you very much, sir, and thank you all participants. Thank you very much.
Okay, so IT is that tea is ready outside. Please join. Recording is recorded.